I've started recording.
Just a minute, I'll join. I'll join. Just something
Uh,
is wrong with my headphones.
okay, all right. Let me put one message. Join, guys. Yeah, I felt recording on OBS. What is that? I felt while recording on Google Meeting, I leave my privacy. Everyone got to see my other tabs and recording of on Google Meet possible for all. Actually, I will upload that video na. So we'll send a link. You people can see. Earlier I did the same. Okay. So guys, oh, Akhil has been okay. Hello, Akhil brother. Okay, okay guys, let's get started. Yeah. So the first question is explain centrifugal pump and parts and function of that. Who would like to go first? Who would like to go first? Should I?
कोई नहीं है क्या?
Kamlesh bro, you are tried. You tried.
Okay, I'll try.
Okay.
Okay, so main parts of centrifugal pump are casing,
Hmm.
impeller, shaft, strainer, and speed check valve. Uh, water is stuck inside the impeller through eye of the impeller, and because of the like rotating motion of the impeller, uh, the fluid gains centrifugal energy. Sorry, kinetic energy, and because of centrifugal force, the fluid is like pushed towards the radially outward, and the volute casing is designed so that while the liquid is flowing, the cross-sectional area increases, so the pressure is built up.
All right.
And thank you.
Haven't
And
you missed out on gland packing?
Hmm.
yeah, and gland packing. I didn't mention that, but is that like we must mention it, right?
Yeah.
Yeah, that's the most crucial because otherwise your water will leak from the shaft area.
Yeah, yeah, gland packing. That
Then after your explanation will become waterproof.
Shall I tell?
Yeah. You
Uh,
people only tell. I am blank.
Parts of centrifugal pump are foot valve or a strainer from down, and then suction pipe and pressure gauge and impeller, casing, and delivery pipe and delivery valve. That's it. And first of all, the centrifugal pump will works on the principle of a rotodynamic principle, in where the suction is created at the eye of an impeller. When impeller imparts the centrifugal force to the water, and it will pushes outward from the casing to the discharge system. So this is the principle, and working means it will first suck the water from the this one footwall or a strainer. Footwall is a one direction valve, means like it will allow the flowing only in one direction. So it will suck the water from that, and when then the water enters into the eye of an impeller, then it will comes out through the guide vein, and as it hits the impeller, the centrifugal force will be imparted on the water. Then as it comes outward, then the area of the casing will goes on, area of the pipe will goes on increases, so the kinetic energy of the water is converted to the pressure energy, and because of that, then it will comes out through the delivery pipe with the high pressure, and as the water goes through the delivery pipe, the potential head will also be created eventually.
Potential head.
But then potential energy means like sir
Hmm?
told this Ganesh sir, as it
Yes.
will goes to the delivery pipe, no, then a potential energy will pressure energy is converted to potential energy like that.
Okay. Like after discharge.
Yeah, after delivery pipe, through the delivery pipe water goes, no, then the
Yeah.
potential energy will be created because it will go up, no, so like that.
So we only stopped after explaining that at discharge side pressure energy is created. You go
That
one
much
step
also is
further.
fine. And I missed the gland packing.
Miss.
You
Gland
also miss
packing.
shaft and motor.
Yeah.
Yeah,
Make. Uh,
that is also one.
yeah. Then explain then. Mm, What is the purpose of that shaft and gland packing?
What?
What is the purpose of that shaft and gland packing? You just.
Gland packing purpose. Gland packing, it will basically it will prevents the leaks. Means if the pressure inside the this one casing, if it goes below the atmospheric pressure, then it will avoid the leak of an air entering inside, air entering. So, and if the pressure is more inside the pump casing, then it will avoid the fluid leaks. So yeah, basically it will seal the this one, seal the casing inside there.
All right. All right. Anyone else?
Mainly, it is so that you want a seal which is continuously going to create the seal while this shaft is spinning. So you have a spinning shaft in the middle, plus you want a seal. So for that, we need this gland packing, which is the thin strips of carbon-based material. So you can just keep on rolling it around and then compress it a little bit, so it forms a seal.
And it will avoid the corrosion also. Gland packing, I told stuffing box, sorry, function. So main function of stuffing box is what I told earlier. The gland packing, it will avoid the corrosion also, corrosion of the shaft. And it will also the cools the shaft. Means like before, because the shaft is continuously rotating, the heat will be produced. So there is a latent ring. So from the discharge valve of the pipe, the water will be go through the holes of an latent ring, and it will cools the shaft, so that
Yeah,
it
but
doesn't get heat up.
Are you supposed to cool the entire shaft or just the bearings? Because the gland packing is
Bearings,
very small
only
and
bearings.
the shaft
uh,
is huge. So that cooling will
uh,
not suffice
Not
because
entire shaft,
uh,
yeah.
only
actually, I
bearings.
have a doubt. Aren't we supposed to mention a stuffing box instead of gland packing? Because gland packing is that white stuff you put in the stuffing box, no?
Yes.
It's actually called stuffing box in main engine. This is called a sealing
No,
box.
no.
Stuffing
What
box
order? What is it
comprises
called?
of the gland packing and latent ring, right?
I think it's called
Mechanicals.
sealing box in terms of when you talk about centrifugal
Sealing
pump.
box.
Yeah, and stuffing box is for main engine where you want to separate the oil between the top
Yeah.
and bottom,
Yeah,
Yeah.
it's on
cleaning
the
that's separate.
con rod. Yeah, it's on that con rod, right?
See,
Yeah.
I today studied that we can mention it like mechanical seal or stuffing box.
Mm-hmm.
A mechanical
And
seal, sir told that it is bolted or something, it is fixed, means like mechanical seal, stuffing box is same, yeah, I don't know.
No, mechanical seal.
I think the main difference that sir mentions
No,
is,
no.
let's say for example
In,
you have something of high
in, is
temperature or some heavily corrosive
stuffing
chemicals.
is stuffing box is the entire assembly over the rotating stuff.
Okay.
Gland packing, it is a part of the stuffing box. The stuffing box is the entire
yes,
packing assembly over the rotating stuff.
yes.
Okay. Now my turn. Pardon me if I do wrong. Explain it like centrifugal pump. Let's start with the definition of pump. Pump is a mechanical device that transfers fluid from one place to another place with the help of prime mover. Talking about centrifugal pump, it works on the principle of centrifugal force. And centrifugal pump has impeller. That impeller is connected with the help of shaft to the prime mover, that is electric motor. When electric motor switches on, the shaft rotates and then impeller also rotates. While rotating, impeller create negative pressure at the eye of impeller, and water is sucked from that, and when the impeller rotate it radially, water is pushes radially outwards. Okay, due to centrifugal pump force. And if you see discharge side, the area is goes on increasing. So when area goes on increasing, the velocity will decrease according to equation of continuity, av equal to constant. And when velocity will decrease, kinetic energy will decrease, and kinetic energy will decrease, then pressure energy will increase, according to equation of Bernoulli. And hence we get discharge, hence this is the way pressure energy is created at the discharge side. Talking about parts of centrifugal pump, the main parts are shaft, um, shaft and electric motor, stuffing box or seals, and bearings, uh, volute casing, and uh, impeller blade. And talking about the function, let us start with the shaft. Shaft is to give a to a shaft is fixed to connect impeller with the electric motor, and bearing, then after bearing is for to smooth rotation of that impeller. And then after stuffing box is the purpose of stuffing box to seal the to make it to seal it to from leaking of water or anything, any chemicals from that. It In seal we have gland packing and mechanical seal. Mechanical seal are so costly, that's why we generally use gland packing. That consists of lantern ring. It is a type of gasket that is fitted for to seal it, and for cooling purpose also, and for lubricating purpose also. And bearing I have mentioned, volute casing. That's all about centrifugal pump from my side. Did I miss anything?
Yeah, yeah, yeah.
What is that?
Actually, you can mention the main part of the centrifugal pump, like impeller casing, suction pipe, its foot wall, and strainer delivery pipe. Then you can mention shaft, electric motor, stuffing box, gland packing, jacket ring, gear ring, like that.
While explaining now, my mind works with the efficiency of 70% only. Or in
Okay, okay.
30%. I had the idea of the foot valve that joined with the strainer for sucking through suction pipe. A foot valve is a non-return valve. We use that for to prevent it from priming, like entering of air. If That's why you
Not
we
draining. It is there to prevent the draining out of liquid from the suction pipe.
if it will not fix a foot valve, non-return valve, there may be chances of sucking air, sucking.
No, 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 no.
There may be
What will happen if there is no foot?
there may be
There
chances
is
of
if there is no footwall.
water will go down, water will get down,
Yeah.
and there will be air automatically in the pipe.
Yes, yes, yes.
Yeah.
Second thing
Actually,
is also
while
the strainer can help avoid any unneeded components, because once they go into the high speed of the impeller, it can cause damage to the casing on the inside.
yes,
Okay, okay. Actually, foot wall is an RB wall which is prevent the backflow of the fluid in the suction pipe.
Okay, guys. Now let's
And Avito, last time you told that filter will also will be there. Where will be the filter? That only is.
that Steiner is only filter.
Oh, Steiner is on the filter.
Stain Stain is a kind
okay.
of the filter which the filter the sediments such as sand, dirt, and grit.
Okay, okay.
So
Okay.
basically, what happens is
It is connected.
sometimes you might
It is
have it
connected
coming
with
from a
foot
tank
valve.
which is at a higher height. In that case, you will not have the foot valve because it's already coming from a higher height. There's no chance of air entering. In that case, you will only have the filter.
Okay, okay, got it.
Okay. Now we'll move with the next question. Anything we are leaving behind in case of centrifugal pump?
Application of centrifugal
Oh,
pump.
there is. It's the next question for that. We'll discuss in that. Okay.
Okay.
The
One
second.
last question.
Oh yeah.
It's about the gland packing. In reverse package, sir has mentioned there are two materials used for gland packing. First one is
Mechanical.
Kevlar, and second is graphite. Right?
Which one? Graphite is the.
Graphite and Kevlar. I think someone has posted a question on the group asking about choice of material for the gland packing.
Not sure about Kevlar, but graphite, yes.
Yeah. We
I
don't
can't
use
remember
the
the
Kevlar
second.
because
I think
Sir
is it
says in
Kevlar or
reverse
what?
package that's only graphite, na?
And what's the other one that is used in case of like corrosive liquids?
Let me check here.
I don't know, like sir it says in mechanical sealing, graphite and carbon is used in mechanical sealing.
That gland packing is made up of graphite only, na?
Sir says in
There are
reverse
grand
two.
package
packing
graphite
made
only.
of the graphite composite.
Yes, I'll check and send it on the group. There are two materials
Sure.
sir has
Yeah,
mentioned. One is for like regular material, and second one is for like corrosive materials.
chemicals, yeah, makes sense.
Uh, gland making. Mechanical seal is also made of carbon and graphite.
Graphite.
Okay,
Yes.
and
Carbon and graphite.
gland packing is made up of graphite. It is very soft. That's only. Uh,
I'll check and I'll send
okay,
it on group later.
all right. Guys, the next question was how pressure is created. Like we have already explained it, na? How pressure is created at the discharge side of the centrifugal pump.
Yes.
Ev Evito, Kamlesh bro, like when I was explaining the pressure when why pressure energy is created at the discharge side of pump, while explaining the equation of continuity and while mentioning the Bernoulli equation, it was right explanation, it was correct explanation according to
And
you.
I
another
think
thing
you
you
should
have.
mention.
Uh,
I think you should mention continuity equation instead of Bernoulli's equation.
No, no, first
Or is
continuity
it Bernoulli's equation?
no,
no, continuity equation is correct, I feel.
oh yeah,
Yeah.
area is
Uh,
increasing.
Yeah, that is the main reason because the pipe is increasing area. No, because of that increasing area, velocity is decreasing. So A1 V1 equal to A2 V2. That's the proper formula.
Okay, and when velocity is
I
decreasing means kinetic energy is decreasing.
Yeah,
Energy is
both
decreasing.
the laws are
both.
applicable over there, but
Yes.
like
Uh,
continuity equation will be more what we call it.
Bernoulli
I think
continuity
I think
equation is nothing but a sub part of Bernoulli equation from Bernoulli.
Continuity is basically conservation of mass.
conservation of
Yes,
Yeah,
mass. Continuity
and
equation.
conservation of mass
conservation
and
of
So
mass.
basically, if 1 kilo of water is sucked in, 1 kilo of water will come out, but it might come out at a higher pressure because it will have a low
yeah.
flow but more pressure.
Yeah,
But basically, 1 kilo will come out. So that's basically the conservation of mass, which is taken into account for all pumps.
But
Yeah,
you can
because
the
in
continuity
Bernoulli's
equation as
equation,
well as the Bernoulli equation.
no,
As
in
we
case
are
of
talking
Bernoulli's
about
equation, there should be incompressible flow, and there are a lot of like assumptions done
So
for the ideal fluid. That's not applicable for like continuous
now
equation.
I got you.
in
Now
the
I got
casing section, there is a Bernoulli's equation is applicable. When there
yeah,
is incompressor fluid, I read in MCQ question,
yeah.
Bernoulli's equation
No,
only
no.
applicable
What
in
I think
casing
is we
section,
are
user section.
increasing the complication unnecessarily by mentioning Bernoulli's
No,
equation.
no,
That's what I was trying to say.
So
but
you
no no
you increase
we are talking
area.
about in terms of the energy
uh,
applied the Bernoulli equation because of the
Mitch,
kinetic energy change into the pressure energy.
see,
That pressure energy after that change in the potential energy at the discharge side of the tank.
see, potential. There is no much high difference, so we neglect potential energy
Yeah, yeah, yeah.
exchange.
You can
No no
mention any one of them.
yeah.
So I agree with Ejaz brother, but see, in Bernoulli equation there are a certain assumption that is flow should be steady, flow should be in streamline, flow should be there should be incompressible fluid. There are three major assumptions. Isn't or something I am lacking?
Ideal fluid.
I,
You are said true.
but fluid with moving with high velocity is compensate that ideal fluid concept. If so,
Yeah, and water is assumed as an ideal fluid, so it is
yeah.
Okay,
not.
okay. Gyan, you are telling that Bernoulli equation he has said that. Then what about the seed? What I air fluid?
What?
Air is the ideal fluid.
No, no. Now I got you. Like,
Air is the ideal fluid.
but high velocity air, like air moving with higher speed, is applicable for Bernoulli theorem, Bernoulli
The
equation.
same here we
Air
are
is
talking about energy
air is
conservation.
somewhat close. No, no, no. Air is somewhat closer to the ideal gas.
No, no.
Like it's considered as
What I have heard,
close as it can be.
the same doubt I also got. What I have heard, the if fluid moving with high velocity, na, it will act like an ideal only, and it will follow Bernoulli equation. Avito, are you
In
having
case of
any
free
idea
vortex
regarding this?
flow, you know, I
Actually,
see that
Mainly, what
actually,
we can say is
this is thought that in a gate where the teacher mentioned Bernoulli equation as well as the continuity equation in in some of the centrifugal. So that's why I'm saying.
And someone
I
just
also read that the in case of free vortex flow,
uh,
Bernoulli's equation is applicable. In
yes,
the casing
applicable.
where is a free vortex,
In casing, in Bernoulli, or sorry, in centrifugal casing, there is not. This is the flow is called vortex flow only because of the circulation. Free
free
vor-
vortex
Forced,
flow.
for
Free
isn't that forced vortex?
it is.
force vortex flow due to in the impulse section there is force vortex flow. Whenever
Okay,
we
okay,
apply force
okay.
I am not
to
sure about it
rotation,
is free or forced, but it is vortex flow because of the circulation of water.
I, I, I
No, no,
I am 100% sure this is
no,
a
no, no.
free vortex flow in the casing section.
Simple flow,
In the
simple flow
casing
is the
section.
uh, yeah, like wash basin, like a wash basin is the free vortex.
Uh,
Here we are use the power output, electric power output. So
I am
Yeah,
saying that
it's
it is the
forced.
combination of free and force. Force vortex flow in the
Okay.
impeller section. When we apply force on the impeller to rotate,
mm.
and free vortex flow in the casing section, we did not apply. Fluid automatically flows in the casing. This is free vortex flow.
uh,
Summation of free vortex and force
yeah,
vortex. In
yeah.
casing section free and the impeller section there is force. I am 100% sure about
Yeah,
this.
okay. Reverse force. All right.
We can just say that you can use any of to it. Just be ready to support whatever you are saying.
Yeah, and be ready to explain Bernoulli equation that I am very good at it.
Yeah, 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 yeah.
Okay.
I would
Now
prefer not to get into the vortex part of things.
Yeah,
we
yeah.
are also
I'm not really,
we are also
I won't even
confident in
mention any of it.
I
Next question is the formula only.
formula was like a gradient of something was constant in vector flow or in vortex flow.
Grand topic.
It's a grand topic,
Okay, I
yeah.
think that's enough. Right?
Okay.
Yeah.
All right. We have completed two questions. Like we'll be moving on third. What happens if air is present in suction side of centrifugal pump?
Hello,
Yes.
hello.
Yes.
Can I explain?
Boss.
No. चलिए इंटरव्यू हो गया चुप बैठ
Kiran bro.
you
Kiran.
just say if we are saying it right or not.
Yeah. Kiran bro, what you have to do? Now your boss, judge, jury.
Yes,
So you will
yes.
काय का boss रे काय का boss?
no, no. You will give tips to
bro, you
everyone.
cleared it.
Uh,
So
Yes,
See,
okay,
that's your task for
yeah.
right now.
Now you are
okay.
jury. You and Avito bro. You can give some tips that what we can add and what we should avoid to explain. You can give some tips. We will be explaining in our way. Okay. So
Yeah.
Can I explain?
yeah, go ahead.
Okay. Whenever the air enters in a suction side of the centrifugal pump, there will be a initially when air enters in a suction side of the centrifugal pump, air will get into the impeller, and it will impeller. There will be as sir explained in the form of the bricks of the water. So when water density is higher than the air by 1,000 times, so air is compressible and water is an incompressible fluid. So when air get into the impeller of the blade, it cannot move the water. Means the one section whenever it moves, means water one section of the water when moves, then another section can move. So if the air is there, it cannot compress. As it is a compressible fluid, so it cannot move the water. So because of that, there will be and it cannot even suck the water also anymore. So it will start to dry run. Means like it will impeller will start to run and dry. Means pump will start to run and dry, and it will get heated up, and eventually it can damage the this one windings and casing.
Other mechanical components.
Yes, correct. Is it
So,
proper?
Can I try now?
Yeah.
Yeah, it was.
so I am saying
Can I
that
try?
Yes.
when you ask the question, can I say that the complete run in air or little bit amount of air is present in the centrifugal pump? If little bit amount of air is centrifugal pump is present, then we use priming unit, so it will leave it will.
Um,
Right now, I cannot answer it right now. I did not get it.
so you can make a two case.
Yes,
Suppose
I
in case one,
understand.
if
Mm-hmm.
little amount
Yes.
of air is, then we can use priming. And
Uh,
but I have just asked the repercussion of that having air in that pump. Kamlesh bro, you can go ahead.
Okay. So what will happen if air is entering in the suction pipe? Pump will pump out the water which is present inside a casing, and after that, air will enter the casing. But because of low density of air, it won't be able to generate enough centrifugal force to lift the water from the source. So the discharge will be stopped and pump will run dry, and it will heat up and get eventually will get damaged.
Okay.
And if the amount of air entering in the pump is very less, then it will just reduce the discharge and the air will be pumped out along with the water.
No, no, hello, Kamlesh. If the small
Yes.
quantity of air is present at the suction side, that causes the cavitation. Basically, small quantity
No.
of air means the small vapor, small bubbles, it acts as bubbles, and it goes
Okay.
inside that high pressure region, and where they collapse, that causes the cavitation.
Does
Actually, I think we discussed this question with the Arvind sir, and he said uh, air won't cause any cavitation. I think.
listen? Does air makes suction pressure low or high? Like presence of air will make suction pressure low or high? Tell me the answer. L-
if air is present in the centrifugal pump, then too much of negative pressure does not create it because air is a compressible material. So
Okay.
we
It will
cannot
lower
move
the
the
suction
air.
pressure.
It will lower
And
the
then it is the only cause of then it is the only reason of cavitation, lowering of suction pressure. That's why not it is possible. Arvind sir is wrong. Maybe if you go
Yeah,
through the
maybe,
logic.
नहीं
maybe,
अरे
maybe.
अरविंद सर ने ऐसा बताया था, मुझे कंफर्म है कि उन्होंने ऐसा बताया था कि अगर स्मॉल क्वांटिटी की एयर प्रेजेंट हो जाएगी तो सेंट्रीफ्यूगल पंप को
Uh-huh.
डिस्चार्ज कर देगा, ऐसा बोला था। क्योंकि वाटर
Yes,
वाटर
yes.
थोड़ा एयर के ऊपर फोर्स लगाए ना, थोड़ी एयर है, ज्यादा वाटर है, ज्यादा वाटर थोड़े एयर पे ऊपर थोड़ा 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 प्रेशर लगाएगा, उसकी वजह से वो एयर
हाँ,
बाहर
वो
निकल
बबल्स के
जाएगी, ऐसा बोला
फॉर्मेट में बाहर निकल पंप आउट किया
था। हाँ
जाएगा.
हाँ, पंप आउट के जैसा बोला था। बट ये आंसर मुझे एक सीनियर ने दिया था, रोहित कौर, मुझे स्मॉल अमाउंट ऑफ एयर प्रेजेंट एट कॉज कैविटेशन।
मैं अभी ये सवाल
And
पूछने ही वाला था. If there is entering in the pump, like suction pipe, then will it cause cavitation?
Yes, it will cause.
yes, अरे
Okay.
तो एक ब्रिगेंजा सर का इंटरव्यू था, तो उसने ये सेम
Mm-hmm.
एक्सप्लेन किया था। स्मॉल क्वांटिटी ऑफ एयर इज प्रेजेंट एट सक्शन साइड दैट कॉजेस द कैविटेशन, एंड too much amount of air or casing is full with the air, 100% of air, that causes the heating of that is the impeller is not able to displace that air, ऐसा।
Okay, तो
So,
select हुआ कि नहीं?
हाँ हुआ ना भाई, सेलेक्ट हो।
All right then.
Supplemental question.
Okay, then हमें मानना चाहिए.
then we agree.
नहीं नहीं, now Kiran has mentioned it, like now it makes sense that because cavitation is like, let's just ignore the suction pressure and vapor pressure. What's happening here is implosion of the bubbles. So if there are bubbles present, then there should be cavitation.
Air is nothing but what?
Yeah, it's the bubble, right? So if it is entering the pipe, then there should be cavitation.
It's
So yeah, it's
So basically, air
right.
in the water acts as a bubble.
yeah, because
Yes, yes.
at that section, the when where there is air, there the section will be of lower pressure, negative pressure, and the high pressure liquid will go through and cause implosion, isn't or not? Explosion or implosion, what is it? Some cause explosion something. Did I spoke anything wrong?
It's implosion, not explosion.
It's implosion. Okay. So I was saying that if air will be present, that will act like a negative section, lower pressure region in that pipe,
Yes,
and the liquid with higher pressure will go with very fast momentum and will implode there. Isn't or not?
yes.
Okay.
That's right.
All right. Anybody else would like to explain? No. Now then it's my turn, yaar. Always when my turn coming, no, my nervousness uh, increases, and that is not follow any Bernoulli principle. Okay. So what was the question here?
What will the effect of air in entering in the suction pipe?
Okay, so the main effect will be heating of windings. Uh, there is a chance of cavitation and
Ah, it,
uh, what?
okay. I mean, what I wanted to say is, सीधा heating of winding पे मत जा.
So I will later
Pump dry
explain
run
now.
करेगा वो पहले बता.
Okay. So effect I will be explaining like there is a chance of cavitation, there is a chance of impeller will dry run, and there is a chance of hitting of windings, and there is a chance of damaging of mechanical components of the centrifugal pump. So I will be explaining when air will be present at the suction side of impeller, what will happen when impeller tries to suck the air. Since air is compressible, it will not get sucked, rather it get compresses, and so the next section of will not move ahead. And since we know the air is 1,000 times less denser than the water, so the centrifugal force that will be generated will be 1,000 times less. And what will happen, it will run dry, and it will the next section will not move ahead, and heating of windings and will happen. That's it, yeah.
अरे वाइंडिंग नहीं हिट होगी रे, केसिंग हिट होगी, वाइंडिंग कहाँ से हिट होगी?
One
अबे
thing
यार.
is, yeah, how a winding is going to get heated because motor
हाँ
doesn't
वही
know
तो.
if your pump has water or
Exactly.
not.
Yes, yeah. The casing will be heated. Okay.
Maybe one thing you can say is the gland
इसीलिए
packing
बोल रहा था
also
कि
will
पहले
start getting heated
पंप ड्राई रन
because
क्यों हो रहा है
yeah,
वो बता, और बाद में
Casing will heated,
अरे
yeah.
जो
ज्ञान
कुछ भी
ज्ञान
इफेक्ट
ज्ञान
होंगे वो
थोड़े
भी,
आंसर
बिकॉज
करने
इफ
पहले
यू विल मिस
ऑर्गेनाइज
आउट ऑन द मेन थिंग.
ऑर्गेनाइज कर थोड़े आंसर, मतलब पहले बोलना कि डेंसिटी, उसके बाद कॉम्प्रेसिबल इनकॉम्प्रेसिबल फंडा लगाना, उसके बाद
हाँ.
वो impeller is not able to displace that air because density of air is मतलब जितना density of water, ऐसा कुछ मतलब आंसर ऑर्गेनाइज कर थोड़ा.
बस वही मैं करने के
आप
लिए 3 बजे
क्रोनोलॉजी समझो.
बस मैं वही करने के लिए 3 बजे बैठा था, फिर अचानक सो गया यार, अभी थोड़ी देर पहले उठा हूँ. दैट्स वाई.
दैट्स द एगनी ऑफ आवर लाइफ.
फिर इससे क्या होगा कि अब जो है मैं अपने इस ऑर्गेनाइजेशन वाले पे काम करूंगा, क्रोनोलॉजी. बिकॉज व्हेन आई एक्सप्लेन ना, समथिंग कम्स इन माय माइंड, आई जस्ट स्पीक लाइक आई डोंट नो व्हेन दिस concept of what I have said, centrifugal force will I have to speak, or the density concept I have to speak. I have to organize, and I will do that later.
ये जो the you mentioned that winding part, no, that is valid, like relevant in case of uh,
No,
that we close that discharge valve while starting the pump, no.
Mm-hmm.
In that case, that's where it's applicable, like relevant.
Okay.
Okay, so if we are done with this question, I have one
Okay.
interesting question, which is
Okay.
out of the like.
Okay.
Okay, can I?
Yeah. So.
Uh,
Just before
can
that, one
anyone
more thing
explain
we
the
can say.
difference between? Okay.
Yeah, we can also say that since the gland packing bearing gets cooling
Hmm.
through the discharge valve water, it'll let if there's no pumping taking place, that water also might stop. So you might have your shaft which is spinning at a high speed, but no cooling from the lantern ring. So even your bearings might start burning out and then might start rattling and stuff like that.
Hmm.
Rattling or rattling of bearing.
So rattling basically means like violent vibrations.
Babbling.
Rattling is like imagine no, imagine you have a bearing and उसके जो balls रहते हैं वो थोड़े wear out हो गए, so there वो play आ जाता है bearing में, race में जो outer race रहती है उसमें play आ जाता है, and it just makes that cut
So
sound.
best example is think about a fan on the first day versus after some
Yeah,
time it
yeah,
just starts
exactly.
like shaking at all over the place. It completely loses its balance and all of that. So imagine that to a pump is not going to be good on a high speed shaft.
Bearing is situated outside of the stuffing box, right?
yes.
That is
Usually what
Then
happens?
that
No,
is
no.
all.
then
Usually what
See,
happens?
see, see
The
there.
gland packing is get damaged.
See there
बस
is
इतना ही.
there is
okay.
also bearing for the mounting of impeller. Without bearing, how impeller will be mounted and will rotate? Isn't it not?
अरे अरे बेरिंग मतलब वो शाफ्ट सीधा मोटर से निकलता है. अगर शाफ्ट लंबा हो तो बेरिंग लगती है वो भी पंप के बाहर, और इम्पेलर के सेंटर पे सीधा शाफ्ट
Those are
कनेक्ट
two
होता है.
different bearings. One bearing which is talking about, let's say the shaft is very long, then you need support in the middle, otherwise it will start
yeah.
bending. That is the outside bearing. But where the
Okay.
gland packing is connected, the something has to be there. It is blocking that entire area. So there also there's another internal one which the lantern ring is cooling.
Okay, inside the stuffing box
Avito,
also there is
is that?
another this one bearing.
Yeah, yeah. I
What?
think Avito, it's not. Just correct me if I'm wrong. It's not a regular ball bearing. I think it's called as
Yeah, it's not a
something
regular ball bearing. It's just sort of a setup which has a
bushing
groove
bearing or
over
something.
there. Yeah, just a groove type of a deal.
Are
Yeah,
you
it's
sure
something
about
like
that second
bushing
bearing?
bearing or like.
Yeah, Kiran had made a point that there will be a bearing outside, because if bearing will be presented inside that, in case of impeller, there will be creation of blockage. I have just.
There is two bearing, one outside the stuffing box and inside the stuffing
The one
box.
which is
That's
outside
what.
is actually called a coupler, where your motor connects to the shaft. So somewhere there you might have a coupler, so that in case the shaft is long, in there you might have another external support. So if you
Coupling.
have a support, I cannot make a fixed support because the shaft is rotating.
Mm,
So there I'll have an external bearing.
okay.
Okay. Okay. And
The
discharge water will be cooling only the inside the stuffing box wala bearing, no? Only that one only it is cooling.
Yes,
Yes.
Yeah.
Okay. Yeah.
all right. I
because
have.
that bearing is something like a bushing. It's not a regular like ball bearing or stuff. It's something like bushing.
What is
That's why
Okay.
it
bushing?
needs cooling.
What is
Okay.
bushing?
I'll just share the diagram all laterwards,
Yeah.
because
Okay.
in bushing you can just say, if you have seen that motor, like toy car motor.
Toy car motor.
Yeah.
I mean, you get those small motors we use in projects and all that stuff. DC motors.
Small DC
Yeah, yeah,
motor.
yeah.
Yeah.
I
Yeah, yeah, yeah.
remember.
Okay, so if you see that on that metal part,
Mm.
there is this like where the shaft is coming out. There is small ring present there.
Yes, I remember.
Yeah, it's sort of like bushing. Uh, I think it's something called as a bushing bearing, or like I don't remember the exact
Bushing
word,
bearing.
but I'll.
Let me search. And yeah,
So
I'll
we'll
say.
basically find the image and send it later. But now I think
Yeah,
Kamlesh,
yeah.
we can come to your interesting
Yes,
question.
yes, yes, yes.
Yes. Okay. So, can anyone explain the difference between fan, blower, and compressor? Centrifugal. Yeah, just fan, blower, and compressor. Yeah.
Fan blower and compressor. Anyone? Judges? There are three judges in the group. Fan blower. The first.
So looks like
Hello.
maybe, yeah. Okay, Kiran can go.
Mm,
Okay, so basically the blower is used to increase the velocity. And talking about the compressor, it is used to increase the pressure of the air.
Pressure. One is for pressure and another is for velocity of air.
Velocity.
What
So
about fan?
basically, what we have found that blower. So basically, blower is like the. So we have created this. That is the negative velocity at the front. Because of that, backward air come in front because of that negative pressure. So this is the continue supply of that air because of that difference in the velocity.
Okay.
Okay, in a
And
turbocharger, it is a blower or a compressor in turbocharger?
Oh, it's the compressor.
It's
that's
compressor.
where I got my question.
Okay.
What
So
Because
Because
question
somewhere
is
hello,
that?
mention
hello,
it
hello,
as a
hello.
blower.
Basically, so
Yeah.
we have know that the induced draft. Someone know that induced draft or forced draft. We know that.
Yeah,
Yes.
So
I
at
know.
that time, we uses the blower. And talking about the turbocharger, we uses the compressor. Because of the blower, we require the continuous supply, continuous supply for like extracting or giving the air to that furnace or that revealing out that air from the furnace. That for the blower
Chimney.
and chimney. And talking about the compressor, basically compressor means so what happened the basically compressor doing that decreases the volume because the air molecules has the because of the less distance between their molecules, so it basically increases its pressure by reducing its volume. So the blower is not doing anything about the volume, it just gives the supply of air by creating the zones.
Okay, I have next question about that. What's the difference between a centrifugal compressor and regular blower, centrifugal blower? I mean, like how compressor is compressing and not just blowing out the air. Can anyone have like any idea about it? Because
Centrifugal.
as far as I know, in the split ACs we use like centrifugal compressors.
तीसरा. Okay.
So you're saying that the fan that is spinning in split AC is a compressor?
No, that fan is just on the condenser, but there is compressor present inside the that external unit,
Okay, so this is an external
and
unit.
that
So that large fan which is cooling the radiator, that part.
no. That the fan you are talking about is just a like radiator fan,
Yeah.
but the compressor is present. I think either in the it must be in the outer unit because if you put it inside, it will
Yeah, it's
just
too
add
huge
up
and it'll
more
make
heat.
a noise inside. So it's definitely somewhere
Yeah, yeah,
outside.
yeah,
So you're saying there's two
yeah.
fans in the outside unit.
Yes, yes. Not two fans. One of them is a centrifugal compressor, and the
Okay.
other one is just fan. So difference between fan and blower is a fan is used when you need high discharge. So it's not increasing velocity or like it doesn't do that much. It just like there isn't a huge change in the inlet and outlet velocity. It just increases the discharge and flow of the air.
Okay.
Hello, hello.
So,
Yes.
yes.
Eh, the the fan you're talking about in AC, na? It is actually
Mhm.
the air. It is just circulating the air through the evaporator coils. You can simply say that. The fan
No,
which
no,
you are
no, 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 no.
mentioning.
That fan is in
Separate.
the internal unit which you put in your room. No, that fan is for circulation. And
Hmm.
if you see that externally you put on your window or like outside the building, that also has a fan which is connected to the condenser. Sorry, condense. Yeah, and it like increases the flow of air over that condenser.
Exhauster.
No, 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 no. Actually, I couldn't find the difference between compressor and blower. So if anyone has that, like, it will be better.
Allah,
Maybe
hey,
the
sab
best
Kiran
example
just
is
said na
a
compressor.
flight turbine.
What?
So the flight aeroplane, when they have the wings, you have basically the
Mhm.
same rotating blades which are compressing. So it could be the angle on the blades that is making the difference whether temperature increases and
Uh,
it starts compressing, or it is
okay.
just a slight faster air that is going to circulate.
Actually, I would, now you have mentioned it. I just realized in the turbines there are additional stator vanes present inside.
Additional, yeah, basically there's multiple stages of compression taking place.
Yes, yes. But in our regular blower, no, there are just vanes present on the rotor. Okay. But in case of that turbines, there are vanes present on the rotor as well as on the stator also.
Okay.
Yeah. So maybe that's what's making the difference.
Hmm.
Yeah. I think we can just move on to the next question.
All right.
Uh, yeah. If I found anything concrete, I'll just post it on the group.
Yeah, don't forget it.
Yeah.
Now we'll come on gear pump. Explain gear pump.
Okay, this is pretty straightforward, so anyone can take it.
Gear pump is a type of reciprocating pump or rotodynamic pump.
No.
These
It's
are
a
positive displacement.
rotatory positive displacement pump. Rotatory positive displacement.
What is the difference between
It's rotary positive pump.
rotary positive displacement pump and reciprocating pump?
Rotary positive displacement pump.
What is the difference between
Uh,
reciprocating and rotary positive displacement pump?
Reciprocating displacement pump is just your piston pump.
Okay.
Like it has the reciprocating motion
Mm.
basically, and in rotary positive displacement pump, just consider the example of gear where the mass we are moving is moving in the radial manner,
Okay.
like
Which generate
circular manner.
high pressure, reciprocating or rotary?
Reciprocating pumps is
Both will give you high pressure because they are both positive displacement. So if you close the or try to obstruct the discharge side, both will cause high enough pressure to explode the pipes.
Yeah.
uh, can
What is the basic difference of rotodynamic and rotary positive displacement pump? That also pumping liquid by rotation both.
The main thing is
See,
one is
in
centrifugal and one is positive displacement.
yes, in case of like rotary like positive displacement pump, you are doing that unit mass movement and like all that stuff. But in case of rotodynamic pump, you are using centrifugal force or Bernoulli's equation in case of axial flow pump.
In axial flow pump, there is also an application of centrifugal force.
No, no, no. In axial flow pump, you use Bernoulli's equation.
Like propeller is a axial flow, like
Example of that
Yes,
is
yes.
Wilden pump, or is that something else?
Wilden is a
I don't
diaphragm pump.
remember the.
No, actual flow
Yeah.
pump comes under what?
Axial flow pump,
Axial flow
basically, you
comes
can
under
consider
rotodynamic. They come under rotodynamic.
yeah,
you
rotodynamic.
Oh,
can
under
consider
rotodynamic.
turbine
Okay.
of airplane or this
Propeller of
like
ship.
propeller of our ship. Yeah, these are rotodynamic pumps basically.
No.
Okay, got it.
okay.
You said propeller of ship that axial flow pump follow Bernoulli equation like we have studied in a case of centrifugal there is casing where the discharge is happening and following Bernoulli equation. How you would
Mhm.
like to explain in the case of axial flow pump following Bernoulli equation in case of suction and discharge?
So in like in case of axial flow pump, your vane design is very crucial in order to develop pressure.
Okay.
I actually I don't have proper explanation. I haven't prepared proper explanation for that.
Little
But
bit.
in case of centrifugal pump, you are just like rotating the fluid. Okay, your vane angle and all the stuff doesn't like it's almost insignificant. Uh, just that like curvature of veins matter. Is it forward or backward? Because it will create either that.
In centrifugal it's backward curve plate
Yeah, yeah.
in
So so apart from that backward curvature, those veins don't have any pitch angle.
pitch angle.
Okay.
Pitch angle is
Yeah.
for that black control pitch propeller and fixed blade. Okay.
It is
Yes,
creating
yes. If you have seen the computer fan, that can be an example of axial flow pump. That could be an example of axial flow pump.
And why is backward curved vein is for the centrifugal pump? Means just question.
If you
Yeah.
put forward curve veins or like straight veins, what will happen? It will create like churning or
Okay.
like
Like
turbulent flow inside
see,
the
we will come.
casing.
It's a next question. Otherwise, it will be not systematic when we'll go through, because I have
Okay,
put
okay,
in
okay.
description. There is a sequence of question. It's a question in the. Okay, we'll come through that. I was saying that like axial flow pump is an also a rotodynamic pump. So
Yes.
the water, the pumping of water will be rotational only, na?
मैं बताता हूँ क्या इसमें क्या होता है एक्सियल फ्लो पंप इज बेसिकली generating a low pressure region at one side because when it is rotating the impeller is rotating at a high speed, so it is creating a low pressure region at one side, so due to which the water is just sucked by the axial only, and water is sucked along the axis of the shaft, so it is sucked and it is thrown out like this.
अरे in axial flow pump there is not impeller, there is propeller na.
Sorry, propeller. I mentioned it in wrong way.
Gurvinder said impeller.
अरे impeller blades
हो
same.
हो जाता है, हो जाता है, हो
तो
जाता है.
प्रोपेलर ही होगा ना उसमें, क्योंकि एक्सियल फ्लो वाले में अगर हम एग्जांपल देखें वो इम्पेलर तब बोलते हैं जब वो पंप के अंदर ब्लेड रहता है, एक्सियल फ्लो वाले में पंप के बाहर ब्लेड रहता है, अरे केसिंग के बाहर, सॉरी.
So propeller mainly is only when you
अरे
use
एक
like
तो इसमें
backward
स्टेटर
curve
होता है
and shift propeller.
एक्सियल फ्लो में, जैसे मैंने पढ़ा है मतलब एक तो स्टेटर होता है, स्टेटर के इनवर्ट टीथ होते हैं आई गेस, आउटवर्ड टीथ होते हैं, और जो जो रोटर है क्या उस पर एक भी मतलब छोटे से टीथ होते हैं, उसके अंदर घूमता है, इसलिए लो प्रेशर रीजन क्रिएट होता है बाहर की साइड में. मैं उसके डायग्राम भेजूंगा ग्रुप पे, एक बार देख लो.
अच्छा.
मैंने ग्रुप पे इमेज डाला है, देखो.
नहीं आया ग्रुप पे अभी तक.
हाँ, रास्ते में, रास्ते में.
ये क्या है भैया,
आया देखो.
व्हाट इज दिस?
तो दिस इज लाइक एक्सियल फ्लो पंप का एग्जांपल है.
ओके, ऑल राइट.
तो वो जो फैन दिख रहा है ना, वो फैन के एक साइड पे लो प्रेशर जनरेट करता है, एक साइड हाई प्रेशर जनरेट करता है. और ये प्रेशर डिफरेंस जनरेट करने में उसका जो वेन एंगल दिख रहा है ना, उसमें जो कर्व वेन्स है, तो
एक्सियल,
वो बहुत क्रुशियल होते हैं.
एक्सियल फ्लो पंप ब्लेड, पंप ब्लेड.
हेलो, मेरे को एक बार उसका बताना क्या कह रहे थे कि जब केसिंग के अंदर होता तो इम्पेलर, बाहर होता प्रोपेलर, ये
नहीं
कौन सा
नहीं नहीं नहीं,
कंसेप्ट?
वो सीन नहीं है. प्रोपेलर इज समथिंग यू यूज फॉर प्रोपेलिंग, लाइक अगर वो शिप में
प्रोपेलर
यूज हो रहा है तो वो प्रोपेलर बन जाता है, या फिर प्लेन में हो
जो
रहा है तो
हमारा
प्रोपेलर बन जाएगा. बट
प्रोपेलर है ना वो
पंप्स
तो
में है.
पंप्स में इंक्लूड ही नहीं है कभी भी. प्रोपेलर प्रोपेलर
क्या क्या
आता है
क्या.
सिर्फ मूवमेंट के लिए मदद करता है वो तो.
हाँ.
पंप्स में तो है ही
और
नहीं, उसका नाम ही मत लो ना उसका
सी
प्रोपेलर का.
एन एक्सियल, व्हाट टाइप ऑफ प्रोपेलर इज
तो
एन
इसको क्या बोलोगे?
सी.
इम्पेलर ही बोलेंगे उनको, इम्पेलर ब्लेड्स ही हैं वो.
अरे हाँ यार,
इम्पेलर ही बोलेगे क्या?
what
ओके.
type of propeller is an axial pump? An axial flow pump has a propeller
अरे
type of
गूगल गलत है यार, था तो गलत है गूगल.
अरे an axial flow pump has a propeller type of impeller running in a casing. इसमें भी
ओके, तो
केसिंग के अंदर impeller रन करता है. The pressure is an axial flow
ज्ञान
pump is
ज्ञान
developed by the flow of liquid over the blades of impeller. यार गुरविंदर was right यार.
ज्ञान.
मैं ऐसे ही
देख देख, एज
थोड़ा सा
फॉर सेक
कंफ्यूज
ऑफ
हो गया था.
सिंपलिटी, गुरविंदर जी ने जो बोला वो सही है. पंप के केस में अगर बोल रहे हो तो इम्पेलर बोलो,
हाँ हाँ, impeller ही.
अदरवाइज प्रोपेलर का नाम ही मत लो.
तेल लेने गया प्रोपेलर. ओके.
तो आई थिंक ये एक्सेल फ्लो का ठीक, आई मीन आई थिंक इट वाज सफिशिएंट एक्सप्लेनेशन है.
हाँ ना, गियर पंप पे थे ना, वी वर इन गियर पंप
गियर
वाज.
पंप
Shall I
क्वेश्चन
explain?
है. गियर
या
पंप इज ए कंफर्म क्वेश्चन. वर्किंग ऑफ गियर पंप.
ए भैया
कैन
लिख लो
एनीवन
इसको,
Okay.
वर्किंग ऑफ गियर पंप बताओ.
David asked how is
I
the pump
will.
is discharged is creating pressure.
वर्किंग
This
ऑफ
was the
गियर
question
पंप.
asked. Can somebody
I will
Yes,
try. I
I
will.
discharge side?
ट्राई ना ट्राई.
Okay, shall I say?
Yes, bro.
Yeah, yeah, go ahead.
Yeah, yeah. In this, there is two gears which is measured. The one gear is called as a driver gear. Another gear is called as a follower gear. Driver gear is rotated by the motor and it is measured with the follower. As the driver is rotates, it will rotate in turn rotate the follower, and there is a fine clearance between the this one gears driver gear and the outside casing, through which the this one oil will escape. So when the oil will goes when basically this gear pump is used to this one to yeah क्या बोलते हो to transfer the this one oils, means like viscous fluids will be there, no, that only that to transfer that only the gear pump is used. And when the oil enters the this one gear
So how is the suction taking place? Can just explain
uh,
properly, na?
suction in this when this motor will rotates the driver gear, because of that there will be a suction will be taking place. Am I right?
How?
How
uh,
question is how?
means because I don't know
I'll try.
this.
मैं
मतलब
तो बोल दूंगा ट्रिमर पैकेज में नहीं बताया
मैं
सर.
अरे
नहीं
बताया
नहीं नहीं
सब
नहीं आई ट्राई
बताया.
टू आंसर दिस. ओके सुनो, क्या होता है जब गियर्स मेश इन होते रहते हैं, ओके, तो जो गियर्स के टीथ का जो वॉल्यूम होता है ना, वो डिक्रीज होता है.
नहीं नहीं
तो
थोड़ा
जब
थोड़ा
वॉल्यूम
उल्टा
डिक्रीज
बोल
होता
रहे
है,
हो.
प्रेशर
अरे
इंक्रीज होता है,
सचिन.
तो ये होता है डिस्चार्ज साइड में
हाँ ये
हाँ.
डिस्चार्ज
पूरा.
साइड में.
वही
और
वही.
सक्शन साइड में क्या होता है, गियर्स आर कमिंग आउट ऑफ मेश, तो
हाँ.
वॉल्यूम इंक्रीज होता है, एंड दैट्स व्हाई वहां पे निगेटिव प्रेशर क्रिएट होता है.
अब ठीक है.
वॉल्यूम
uh,
इंक्रीज,
uh,
And actually, the
नेगेटिव
meshing
प्रेशर
of the
क्रिएट.
gears has nothing to do
can you
with
explain again, Kamlesh, please?
Guruvinder, you can explain it better.
मुझे
Go ahead, just.
I will just try best. So basically, what is happening is when the gear wheels are moving. So when at the suction side, when the gear teeth are coming out of the mesh, so they are creating a larger area. So due to which the pressure will be reduced. So the liquid will be sucked inside the casing, and it
सॉरी सॉरी. लार्जर एरिया, हाउ प्रेशर विल रिड्यूस ना. लार्जर एरिया मीन्स प्रेशर विल इंक्रीज बिकॉज लार्जर एरिया मीन्स वेलोसिटी विल डिक्रीज, एंड so velocity decrease, kinetic energy decrease, pressure energy increase. You just
uh, Gurvinder, once you explain again, it's like
so basically what happens is that at the inlet side where when the gear teeth are coming out of the mesh, it is creating the area is increasing or the volume has increasing, due to which the pressure reduces and a suction takes place at the inlet side, and the fluid is discharged inside the pump, inside the casing, and then this fluid is carried between the gear teeth and the casing to the other side of the casing, where the gear teeth goes back into the mesh, and the area reduces and the pressure is increased and the fluid is discharged with high pressure. I
yeah.
think I'm missing some points. Actually, I'm out of
One of the
the.
main things will be
Hello, hello,
Yeah,
hello. Can I explain?
yeah, yeah.
Can add some points.
ओके. तो पहले सबको बोल देना, मतलब ये इससे कनेक्ट है वो उससे कनेक्ट है, क्लॉकवाइज एक एंटी क्लॉकवाइज. देखो. सो बिकॉज ऑफ द अनमेश ऑफ टीथ, द वॉल्यूम एट सक्शन increases. That causes the liquid from the suction side is forced towards the casing because of that atmosphere, because of the pressure difference created over there. So when the liquid is come inside that casing, it trapped between the teeth of gear and the casing. So because of that meshing action, the volume of liquid reduces. That causes the pressurized liquid is transferred to discharge side of the discharge side of the gear pump. In this way, the high pressurized liquid.
यार
Yes, Kamlesh.
ये तो कम इसका किरण का समझ में आया. लेकिन गुरविंदर ने एक चीज मेंशन किया कि एरिया रिड्यूस हो रहा है, प्रेशर एनर्जी इंक्रीज होगा. अब प्रेशर एरिया इंक्रीज हो रहा है, प्रेशर रिड्यूस. ये एरिया और प्रेशर तो डायरेक्टली प्रोपोर्शनल है. एट द सेम टाइम वॉल्यूम और प्रेशर इनवर्सली प्रोपोर्शनल है.
yeah. And I need to share my screen
हाँ या गो
to
अहेड.
draw the pump diagram.
यस. हाउ.
भाई मेरे पास मेरे नोट्स नहीं तो वहां से मैं बेटर समझा पाता.
कोई नहीं, इस पे हम
मैं
करेंगे. किरण कुछ कहना है इस पे? Okay.
Let me know when you guys see it.
Okay.
हाँ ये डायग्राम मैंने बनाई थी उसमें इंटरव्यू में.
Okay, so let's say here I have my inlet fluid coming in. Let's say I'm just drawing it as small pieces. So when it comes here, what is happening? This is rotating, let's say, in this direction. Okay,
Okay.
and this will rotate in the opposite direction.
Correct.
Coming out of mesh.
Hmm.
Okay, so what is happening here when this block of fluid comes here? Look at this, specific tooth of the gear pump. It's going to automatically push this. Imagine like this entire thing is going this way.
Hmm.
So when this box comes here of fluid,
Hmm.
this gear will now move next step over here like this. So your box will now reach here.
Hmm.
This box goes here. So basically the wait, what the hell is this? Focus assist. Okay, so basically the way how we having the suction creating is because these individual gear teeth are forcing the liquid into this gaps over here. Here I've shown this massive gap. This is actually a very thin gap, like very fine on all sides.
Fine clearance. Okay.
Yeah, fine clearance just so that friction doesn't build up and your pump doesn't get heated due to metal contact.
Also for preventing escaping of oil.
Yeah.
Okay.
So, but the main thing is the way how suction is happening is I'm showing only on one side. This is happening on the top. So imagine you have two boxes of fluid over here.
Okay.
So when I say box of fluid, it just means imagine one drop. You're considering one drop, but this is happening
Oh.
to all of the thousands of drops of fluid.
Correct.
So it comes here when this blade is spinning now. So this blade is coming lower and lower. So it will capture this block, and the block will then keep coming lower and lower because that blade is now moving lower and lower. Same thing on the top side. This will be another large blade over here, not the full thing, but somewhere here. So when this box goes here, it will keep on getting pushed upwards and upwards inside the casing. So this same block will go all the way from here, within each one of these gaps. So it will go from this box will be within this gap only. So then the next box will be in the next gap and stuff like that till it goes to the output. Now the thing is here, as you said, in this case, they will be meshing into place. So it might cause high pressure. But the thing is here, there's a perfect, complete 100% mesh. So there's no chance of this high pressure and this low pressure area, if it is possible, created to be, related to one another. So imagine it is completely a positive displacement, which means no connection between this side and this side, completely a massive block in the middle.
Hmm.
So that's what I tried to show with these two, teeth completely touching. So there's no chance of pressure going from here to there.
Okay.
So the way how we have the, suction taking place is not because of some low pressure being created over here, but it is mainly that this thing is actually just forcing it and pushing it, all the way through from here to here to here to here to here.
Okay, oil is coming from natural movement only. No, there is nothing like pressure
See,
difference.
see, see, see. There is a fine clearance both side in a follower edge and in driver edge. That fine clearance means area is decreasing, and area is decreasing, so automatically pressure will increase. That's how high pressure is being generated. Talking about flow, that flow will be creating by the followers, driver and follower only, isn't?
Now I am
No,
asking
see,
the
the main thing is you're saying here high pressure will be created, but the thing is from here fluid cannot flow in this direction. So there's no point of your high pressure being formed over here. The way how high pressure is being formed is I have this block of, let's say, this is now in motion. So I have all of these small drops of fluid coming over here. So I have all of these over here, and in this case also from the top it's coming here. Now what if I block this over here? This is a positive displacement, which means it will keep on bringing the next block. So right now there is space, so more blocks can get filled up over here. But after it gets filled up, it's going to keep squeezing these, water droplets or whatever tighter and tighter, and that is what causes the pressure until it's just going to burst from over here. So the central part has nothing to do with why the positive displacement pump is causing so much pressure.
See,
It
see.
is just that
Uh,
non-stop I'm adding more and more droplets. So if there's no place for it to go, it will just explode
now
because the droplets cannot compress.
I have one thing to say. Like in Dream, I am having Dreamer package notes right here. What was Gurvinder was saying written here? Area is decreasing, and I have made a symbol pressure increase, but it's not true, guys. If is decreasing, how pressure is increasing? If you apply continuity equation and equation number only. Avito.
I mean, basically, normally, if area is decreasing, pressure will increase.
Area is decreasing, pressure will increase. What are you saying?
Volume,
Yeah, so
not area.
area
So
in this case, I'm using area because it's a 2D image. So, are you talking in terms of this?
No, I have written here. I need to see go again that lecture. Uh, Here is written area is decreasing and pressure is increasing. So it is not true, na at all. This statement is not true. Who is
Yeah,
अरे
the
in
thing
gear
to
pumps
note
ना,
is whatever
in
is
gear pumps
happening
what is
here
happening ना,
is just a
at the
non-return
discharge
value.
side,
क्या?
at the discharge side there is no space for the
Hmm.
fluid to go back. It's like a locking,
Hmm.
so it is forced to move out, you
Yeah, so
can
this is
say.
what I've shown you. You see this? It's completely touching
Yeah.
edge to edge. There's no
So
chance.
some
It's like a
concepts can
non-return.
be molded.
If I'm still adding more and more drops of water, water cannot be compressed or whatever viscous fluid. So what? Where can it go? It'll either have to break this blockage
Hmm.
or break the pipe.
The non-return part called as the interlocking.
Yeah.
Interlocking.
So
इंटरलॉकिंग हो
the
जाती है,
areas mesh in such a way that there is a hundred
प्लस
percent
कोई और
non-return.
जगह ही नहीं है, सिंपली से दे आर फोर्स टू मूव आउट विद प्रेशर.
Okay. All right.
So yeah, that's basically the working of the this thing.
And not forget to draw the with the leaf valve when the interview asks you to
Yeah,
draw the
sure.
diagram.
Yeah.
Coming to lobe pump, also it's the same thing. Instead of this, lobe will just be like three large sort of leaf
It's easier to
structures.
understand in case of low pump.
Similar to
So
gear
it'll be
pump.
like this.
Area decreasing, cost increasing.
And suction of the lube oil is not because of pressure difference, right? That's one question.
Yeah, it is just being pulled in manually by each lobe.
Yeah, means it is naturally means like there is no pressure
So
difference.
here it is very easy to
Lower.
understand. So you see right here, let me just rub this part. Let's say, okay. So here I have my water coming as
No, no,
droplets.
Ashish, Ashish, it is due
Yes,
to pressure difference.
a suction of this lube oil.
Uh,
This one. Uh,
because
okay.
you can also take some reference with the expansion valve.
Okay.
If you can, like,
Yeah, area is
read
increasing. Means suddenly
because
this lube oil is coming, area will become bigger,
because
so the pressure will become down. So there is
because
a
for
pressure
the
difference.
liquid coming inside the it will have more area to just move freely, so
Yeah.
the
Okay.
pressure will be like
But
less,
imagine this, you're talking about this in case number one.
Hmm.
Uh,
Once the first time, imagine this pump is completely dry, in like this case, okay,
so it has
completely dry
created
pump. Now
negative
I'm
pressure.
adding the fluid. So first time it will come, fluid will come here and just take up all the space. Now where is your pressure difference? Because now it is completely filled.
Hmm.
mhm.
So now it is only dependent on the rotation. So this, imagine this particular leaf. I'll just maybe do a black outline on that. Fill this up. Oh shit. Fill this up. So now it's completely filled. So now there's no chance of any vacuum being created because all of this is here. So imagine this lobe leaf now. This is rotating in this direction and this will be rotating in this direction.
So
So this leaf is now moving. So it is now reached over here. Then it will reach over here. So whatever is trapped below that will be pushed and carried out. And during this whole procedure, the two central lobes are completely touching over here. So this will be a non-return. So imagine here it captured two droplets, here it will capture another three droplets maybe, or four here, and then another two here. And then same thing over here, you have two over here, maybe three water droplets over here.
yes, yes,
When it comes
and
here,
also this
first I'll
this
first it'll
can
start
also
just
be
piling up over here. Yeah, it'll start piling up. Once the once there's no more pressure to go, because I mean once there's no more area for it to freely go, then it will start compressing until it can push whatever object you have, like the potential difference or whatever.
Which is more efficient, gear pump or lobe pump?
They are used for different cases. It's
both
mentioned in
both
Dreamer. I
are
think
applied different
some are
different
used in
ways.
incinerator, some are used in sewage treatment, some are used for Oh yeah, vane pump is used for vacuums. That can create a
Gear
vacuum.
pumps are used
That
for
is used
like
like in
the
fresh water or something.
lube oil transferring and
Gear
fuel
pumps are
transferring.
used for yeah, like
Transferring.
viscous fluid, and low
Viscous.
pumps handle both low and high viscosity fluid. Like the blades you made in a low pump, they interlock each other. Like the spaces will be filled by one space of blade will be filled by the other blade. Like the space there
No,
will.
no, no, no. It's not like how you're saying like one will never hit each other. It's not like when this blade is like this. When this blade is like this, the other blade is not like this. It's not like this. They will completely meet each other so that it can form a non-return lock.
No, no, they will completely meet each other, not at a blade. Just you have shown it. Like they will meet.
Yeah, the shape of lobe is slightly different here. I've just drawn leaves, but basically this is the
The
understanding.
leaf to leaf will not, like blade edge will not meet each other. Meet rather the gap between two blade will be filled by the other blade of second lobe.
Let me just see if I can find a quick animation of that.
Okay.
Lobe pump animation.
Yeah, means what will be the answer of Gurvinder question, that how pressure is creating in gear pump, working principle of gear pump, how if we have to say in words, like now we have understand the mechanism, but how will I explain that?
Uh, See this GAN.
Hmm.
So in this, when entry is there, no, see this. He drawn the red color small box. No, from the suction pipe only you see. Okay, when it is coming, when it comes inside this one, the two gears, no, suddenly the area will become increases, right?
Inside to gear, like at the edge,
Means like
at the edge.
at the veins is there, no, when it come to vein, the area, the suction
Uh,
area of the pipe and the area in which the gear is mounted, both area is different, right?
yeah, correct, correct.
So, when this both areas is different, no, and pressure basically how you can say it is the molecules, means the amount of force which is applied by the molecules. Okay, so when where there is means like in a suction area is less, so less amount of molecules of water is there, correct?
Mm-hmm.
When area has become more, say there, so there is a more space to accumulate the molecules, correct?
Correct, correct.
So the pressure in this more area, where there is more area, there will be the less pressure. Correct.
No.
When the area is less, the
No.
pressure will be more. Means like amount of molecules,
More
force
area will
which
be
is
more pressure, na bro.
Less pressure, less
no
यार
less
ज्ञान
pressure,
बोलो
bro.
तुम.
See,
यार अब देखो.
see,
थर्मोस्टेटिक एक्सपेंशन वॉल्व समझ अच्छे से आता है वो.
नहीं, देख, more area means less velocity, isn't correct or not? Area into velocity is constant according to equation of continuity. अब
अरे भाई.
वेलोसिटी कम है तो काइनेटिक एनर्जी कम, काइनेटिक एनर्जी कम तो प्रेशर एनर्जी ज्यादा. ठीक है
see,
तो
you imagine the pressure. See, you imagine the pressure like a molecules, means like small amount of molecules applying the force like that. So where there is more molecules will accumulated, there will be a more pressure. Where there is less molecules, there will be a less pressure like that.
अरे ज्ञान
हाँ,
थर्मोस्टेटिक एक्सपेंशन वॉल्व समझ आता है अच्छे से.
थर्म, हाँ उसमें क्या
Yeah,
आता है?
तो उस वही है.
guys, can I
वही
try
हो
now?
रहा है
हाँ,
इसमें.
उसमें थर्मोस्टेटिक
Okay.
एक्सपेंशन वॉल्व में क्या होता था?
बस तू बता भाई, याद है मेरे को.
अरे वो क्या बोलते हैं, उसमें वॉल्यूम बढ़ा देते थे हम तो प्रेशर कम हो
तो
जाता था.
फिर बस
इसीलिए बोल रहा हूँ एरिया मत बोल, वॉल्यूम बोल.
वॉल्यूम है, वॉल्यूम.
हाँ
एरिया
तो वॉल्यूम बोलो
बोल.
ना.
पाइप नहीं है ये, पाइप नहीं है ये, वो पाइप का अलग सिस्टम है,
हाँ
उसको छोड़ दे तू. ये पाइप को लेके बैठा हुआ है.
तो
हाँ, इसलिए
वॉल्यूम
बोल
बोलो
रहा
ना.
था कि वॉल्यूम बोलो, एरिया मत बोल.
वॉल्यूम.
ओके. हाँ, तो उसमें क्या है, ये जो गैस, हाँ, तो ये जो गैस से मेशअप होते हैं ना, तो यहाँ पे वॉल्यूम कम होता है तो प्रेशर बढ़ता है. और जैसे मेशिंग से आउट आ रहे हैं तो वहाँ पे लाइक वॉल्यूम इंक्रीज होता है तो प्रेशर बढ़ता है. और आशीष, यू वर सेइंग दैट इट्स नेचुरल प्रोसीजर, इट्स लाइक पंपिंग लिक्विड जस्ट बिकॉज ऑफ दैट रोटेशनल मोशन. ओके. Okay, once liquid enters inside the casing, it's just pushing it. But
Okay.
imagine you need to lift the oil from a sump. In that case, you can't just rely on like it's pushing the liquid. There has to be some suction to lift up the water.
Okay. Yes, yes, got it.
The section is in all the pumps. You can see any pump. In
Okay.
centrifugal
Yeah.
pump also it have to create negative pressure.
Correct.
Okay, got it.
Even in reciprocating pump, there is suction, and
Uh-huh.
that suction is because your like piston is moving down. That's why there is suction. That's why it's lifting and pumping.
तो why?
Okay, okay.
उसमें भी तो वॉल्यूम बढ़ते हैं ना पिस्टन पंप में. देख लो,
हाँ.
कंपेयर कर ले उसको.
और
Got it.
अगर ये चीज तुम
So one thing is
लाइक
in
समझ
centrifugal
रहे
pump,
ना.
yeah. Is there suction in centrifugal pump, or is it mainly once the pumping starts? Since you're anyways priming the pump, we just have a
Uh,
siphon effect also taking in account.
Sorry, what?
So since in centrifugal pump, does first question is in centrifugal fuel pump, do we get the suction created? Since anyways we are
हाँ.
Yes.
creating the priming, so maybe siphon effect takes place.
No. It's not happening. Imagine वो जो impeller रहता है ना, that impeller can like sorry. There's water inside the impeller. You start rotating that impeller, okay? And whatever water present inside that impeller is pushed outwards inside in the like outward of the impeller, okay? Is that clear?
Pushed outwards, yeah. Whatever comes in is pushed outwards into the centrifugal
Yes.
force. Yeah.
नहीं अभी like just ignore the fact that water is coming in. Just
Okay.
like imagine there is a casing and like water isn't coming in. Just focus on the water which is present inside the casing. Okay. Now you start your motor and the impeller starts rotating. Okay. And that water which is present inside the casing will start to move uh, away from the center.
Okay. Yes.
Okay. Now, before that, we know that the casing was completely filled with water. So now that water which was present inside the like center is moving away.
Yeah.
So there is some sort of like low
Gap
pressure
in the
region is
middle.
created
Yeah.
at the center.
Yeah.
And that's where suction is developed, like negative pressure is developed.
Okay.
And that's why like centrifugal pump is able to pump the water, like lift the water.
Like you are
Okay,
saying
makes
that
sense.
when radially pushes outward water, it displaces some amount of water, and while displacing, it creates lower pressure. Then after the suction pressure,
Yeah.
then it able to
Yeah.
create
Now,
suction.
if
Okay.
you're having a doubt of like is it compressing? No, because the water which is being pushed away, no, that water is getting out through the discharge pipe.
Yeah.
The water which is moving from the center is already has left the casing through the discharge pipe.
यार कोई तो वॉल्यूम मेंशन कर रहा था बिकॉज ऑफ इंक्रीजिंग वॉल्यूम दैट नेगेटिव प्रेशर इज क्रिएटिंग इनसाइड दैट गियर केसिंग लाइक
गियर पंप अलग है, वो अलग है
ना. मैं कह रहा
समझ.
हूँ वॉल्यूम जो बढ़ रहा है इसमें जब सक्शन पाइप से इसमें आ रहे हैं वो तो फोर्स अलग काम कर रहा है उसमें कि द फोर्स इज फॉर ड्राइविंग एंड ट्रैपिंग द वाटर एंड पुशिंग आउट बट द नेगेटिव प्रेशर इज क्रिएटिंग बिकॉज ऑफ दैट फोर्स तो तभी काम करेगा ना जब वो पानी उस पर आके टकराएगा. पहले उस पानी को वहां टकराने ले जाने के लिए तो हमें नेगेटिव प्रेशर चाहिए. तो वो नेगेटिव प्रेशर जो वॉल्यूम बढ़ता है उसके वजह से है.
नहीं, सेंट्रीफ्यूगल में उसकी वजह से नहीं होता.
अरे भैया गियर प्रेशर गियर सॉरी
गियर पंप.
गियर पंप के लिए
हाँ.
बोल रहा था.
हाँ,
See,
गियर
best,
पंप
best, best
वॉल्यूम इंक्रीज
example
हो
of
रहा
this
है,
is
हाँ.
तो अब भी
why are
pressure
some
हाँ.
of the pumps in wells like submerged
Like
compared to centrifugal pumps? They are kept up with the long suction pipe.
your impeller of centrifugal pump are not submerged in water.
Impeller is definitely not submerged. Like imagine you have a tank in your house.
Not always,
The
not
pump will be
always.
kept, on ground surface, and then the suction pipe will go down.
Yes. So what's your
But then the
question?
next question is, if suction is being created, why can a pump only suck up suction up to whatever? I think that is 9.8 meters or something, or is it 10.3
10.3
meters?
meter for 1 atmospheric pressure.
Yeah, how does that value come in for suction head? Like, why is that the max value? Is the next question.
Practically 7.5 to 8 meters. Practically
Practically 7.6
How much? 7.5?
to
7.5 to 8 meters.
Okay, 8 meters. Okay, yeah. So how does this value sort of come into play, and why it is restricted? Like, why can't I just, if I'm creating negative pressure continuously, I should be able to even, create suction 100 meters down.
See, when we are creating, suppose if we create minus 1 atmospheric pressure, negative pressure of 1 atmosphere, okay, then it will be ideally it will be able to suck water from 10.3 meter down, okay.
नो नो, इसका इसका एक कॉन्सेप्ट हमें को भी अच्छे से कंफर्म नहीं है ये। उसमें आता है मैनोमीटर, मैनोमीटर मेजर ही उतना कर पाएगा, विस्कोसिटी के पे होता है कुछ। अगर हम ज्यादा ले लेंगे ना तो उसका जो वो होगा ना साइज बहुत बड़ा हो जाएगा। आई थिंक इसके ऊपर थोड़ा सा मेरे को याद अच्छे से
One
क्लियर नहीं है कंसेप्ट।
one atmosphere is equal to 10.3 meter of the water in the manometer, correct?
हाँ, वाटर कॉलम, वाटर
So,
कॉलम।
when
Is it in the
so
manometer or is it in capillary tube? Because I think this 10.3 meters comes under surface tension, right?
Yes,
That is how much the surface tension
yes,
can hold it, and after that it cannot hold it anymore.
correct. It's because of
Manometer is, I think, more to measure out pressure and stuff.
correct.
yeah, means one atmosphere means 10.3 meter of the water column in the
Capillary tube,
not manometer,
in
in
capillary
capillary
tube.
tube. Yeah. Okay, okay. Because of that only means like
नहीं, वो कैपिलरी ट्यूब को मैनोमीटर का है, उसको यू यू ट्यूब में शेप मोल्ड करेंगे ना, वो ट्यूब मैनोमीटर ओ कैपिलरी ट्यूब होती है। लेकिन उस पूरे सिस्टम पूरे उसको इंस्ट्रूमेंट को मैनोमीटर कहते हैं क्योंकि वो प्रेशर मेजर मेजर कर रहा है।
Okay. Okay, so basically, as you said, one atmosphere of suction will be created. But if my pump is continuously moving, why can't I create two atmospheres of suction? In that case, my pump should be able to now have a negative head of, minus whatever 16 to 20 meters. If continuously my pump is creating suction, then it will keep on going. It will go -1, -2, -3 atmospheres
No, no,
of
it's not
suction.
creating negative continuously. It is not creating.
Okay.
It is just creating negative pressure for the initial time when if like some quantity have entered the casing na, it will just keep it will just keep it moving further. It will not like more, it will not be able to create negative pressure because there will always be water at both the sides of the impeller, according to me.
Yeah, so I'm saying basically, why can't I have a suction pipe which is longer than 10 meters?
Uh, on Earth we can't have because on Earth there is 1 atmosphere.
Yeah, but I'm saying the pump can create maybe more than 1 atmosphere of suction,
That
because that is exactly what is happening in vane pump. In the freshwater generator, you have vacuum created by the vane pump.
yeah, suction is created by impeller that is moved by the prime mover with the help of electricity. And if we talk about like question is you are a very good question.
Avito, you only explain, man.
I have no idea of the question. That's why I asked the question.
पता है मैंने इसमें थोड़ा सा मतलब देखा था कहीं पे उन्होंने स्पेशली मेंशन किया था लाइक दिस इज द लेंथ pumped by the positive only positive displacement pump।
वो उसमें
मैंने एक कहीं
मेंशन करते हैं ना
किसी
NPSH
जगह नोट्स
अवेलेबल।
किसी जगह नोट्स मैंने कहीं पे तो ऑनलाइन सोर्स था कुछ
I
तो
basically
they
not found any
mentioned
notes on this, but I just read that the 10.8 that is mentioned in Dreamer package.
yes,
That and then
but
after
like
that,
sir
lower
didn't
value.
mention which pump he's talking about।
The reason how I understood that this submerged positive displacement pumps is because they mentioned that if you keep it on, it will burst the pipes. So which is the pump that burst pipes is positive displacement. So somehow maybe positive displacement pumps have lower suction compared to centrifugal or something is what I'm trying to figure out.
No, I don't think so because in our fields, na, in our fields we have big pumps for like irrigation purposes. They don't have any. You are saying molded or like reverse. They have single pipe, single big pipe in the groundwater.
Avito, I
Yeah.
got
So
the answer. Can
okay.
I tell
Yeah,
Yeah.
this one? See, there is whenever there is when you want to suck the water from the underground pipeline, no. So the sir told that there is one formula that is H atmosphere means the head of the atmospheric head minus this one this head of the pipe means the pipeline how much is the length will be there, no. That's that head. Then minus the friction head. So if the minus friction head minus this one vapor pressure head something he told. If
No, no, no. That is different. You're talking about net positive suction head. That is to avoid cavitation. That's a totally different topic.
Mhm.
no, means like I thought that the H atmosphere only positive term. If all the negative term becomes zero, the head of the atmospheric will be P atmosphere divided by rho g, right? So that because of that, that will be that value will be 10.3 because the atmospheric head is one atmosphere. For one atmosphere pressure, 10.3 meter of the water column. So the 10.3 meter of the length only ideally it can suck. So because of that, I thought that because of that only the pipe length will be that much. If more than that it goes, then there will be cavitation. So this cavitation formula will be applicable, I think.
I think you're getting somewhere closer. It makes some sense now. Let
Yeah,
me try
if
to basically throw it out and just see if I can somehow visualize what you're saying.
this basically that formula you see H atmospheric head minus this the length of the pipe. Length of the pipe minus why because there is a friction inside the pipe. No, if you ignore that friction, that pipe ka friction and minus this one the length of the pipe or no then friction then all other head is in negative. I correctly remember. Which all I am not recalling that formula correctly.
Even the
But
head can be positive or negative depending if it is from a
yeah,
tank or from the ground.
if the tank is underground, no, then the head will be head is a negative
That's
head.
only
If the
plus or
tank
minus
is
in the
upward,
formula.
yeah, that is because the if the tank is upward, no, then the pipe length ka head will be positive. If tank is downward, the pipe length will be negative.
Okay,
Wait,
okay, I got the answer. Let me share and explain.
Okay.
So basically, it did come down to a sort of combination of
मिल
everything.
गया मिल गया.
ओके ओके
I just
यार
revised my
वो तो ठीक हो एक बार
Dreamers
क्वेश्चन.
package na.
हाँ
In Dreamers package, sir also mentioned it's only a reciprocating pump that can lift 10.3 meter.
यार
That's why
क्वेश्चन क्या
the
था?
guy was saying.
व्हाट वाज द क्वेश्चन इनिशियली? लेट मी राइट इट.
देखो देखो देखो. I will just share you a screenshot
Okay,
in the group. Just see it
checking it
once.
out.
यार Avito, what was the question initially?
So
Let me write.
mainly, why do we have this constraint of 10.3
Why
meters
do we
ideally
have
on a pump?
constraint?
But in real life, again, it is mentioned that due to friction, all of those things, it comes to around 7.8 to 8 meters. But why this constraint?
Why do we have constraint of 10.3 meter height of suction,
So basically,
suction?
if I'm
Just see the
sucking the
group
water
name.
from the ground, I can only
Just see the
suck
group
from
name.
10.3 meters deep, ideal condition. If I
yeah,
go to 12 meters deep pipe, it will not work.
I shared the formula. See, I got that formula. NPSH of the available is equal to absolute pressure of the HA means atmospheric pressure plus or minus water head. Water head minus when the head of the water is if you are sucking from the underground, no, then it will be minus. Okay, so minus this HF frictional losses minus that absolute vapor pressure. See, all
Mhm.
the term will be negative, minus only. If you ignore that, you only you can ignore in the ideal condition. Okay, if you neglect those losses, then the absolute pressure head of the surface of the liquid will be atmosphere. So atmosphere head will be 10.3 meter of the liquid column, H water. So
मैंने
NPS
चेंज
available
किया
will be
वो देखो.
10.3 meter.
It is only reciprocating pump sir has mentioned in PPT.
Hmm.
It's he have never said centrifugal pump. Because I know centrifugal pump are lifting water from very much height
So then
downward.
the next question comes: why is centrifugal pump, excluded from this?
जज
These are
साहब.
the questions we should be asking in life.
जान ले लो जान ले लो.
लेट्स मूव विद द नेक्स्ट क्वेश्चन यार. हम भी एक बार निकाल ले फिर शास्त्रार्थ करेंगे.
Okay, but Gyan, just make note of it. We can ask sorry in case he comes live someday.
Yeah, actually, I have a sort of explanation for this.
Okay.
I'm just making it. Give me some time.
Um,
So uh, अभी इसने गुरविंदर ने जो स्क्रीनशॉट भेजा है, अकॉर्डिंग टू दैट इसमें क्या बोला है कि अगर तुम्हारा पंप 100% वैक्यूम क्रिएट कर रहा है, then you can
And
only
reciprocating.
you can only pump it up to 10 meter, right?
Hmm.
And the question was why we are having that 10-meter constraint. Constraint.
Uh,
Okay.
Yes, yes,
Yeah,
yes.
exactly. Okay. So what's happening in this case? Like the remaining part on the reservoir, there is atmospheric pressure is like
सर
built up.
ने भी समझाया है कहीं पे,
Huh?
ये सर ने उसमें उस टॉपिक्स में समझाया है वाले फ्लूइड प्रेशर वाले टॉपिक में स्टार्टिंग के वीडियोस में इन द फ्लूइड इनकमिंग सेक्शन. दैट्स व्हाट आई एम रिमेम्बरिंग. द मैनोमीटर आई नो.
वही ना, मैनोमीटर उल्टा घुसा है पानी के टैंक में, वो हाइट लेता है, उसका एरिया छोटा बड़ा होता है, अगर वो
हाँ,
मर्क्यूरी रहता है तो वही ना.
मर्क्यूरी होगा तो
हाँ
बहुत
वही.
छोटा है वो तो.
देखो अभी इसमें क्या होगा, अगर इमेजिन यहाँ पे सर्कल आ गया, हाँ यहाँ पे 100% वैक्यूम क्रिएट किया गया है, ओके सर्कल में, तो पानी अंदर सब किया जाएगा, बट क्यों? बिकॉज यहाँ पे सॉरी यहाँ पे एटमॉस्फेरिक प्रेशर एक्ट हो रहा है ऑन दिस सरफेस, या इसलिए यहाँ से वाटर अंदर जाएगा, यहाँ पे होगा. तो ये एटमॉस्फेरिक प्रेशर की लिमिट है कि अगर वो एटमॉस्फेरिक प्रेशर 1 बार से ज्यादा है, देन यू कैन लिफ्ट इट टू मोर लाइक हाइट.
करेक्ट. मैं वही कह रहा था, अगर धरती पे है तो इतना ही कर सकते हैं.
Yeah, so this is the first question which is now answered as to why that limit is there. Now the next question is, why is the limit only for reciprocating, not for centrifugal, if that is the case?
It's limit for centrifugal, not for like.
No, in the slides it's given reciprocating.
I think centrifugal pump is able to create more negative pressure because of the high speed of the impeller, because no other pump have that much speed of the impeller.
Are you sure that this limit doesn't apply to centrifugal pump?
That's not
I'm
mentioned in the slide.
I'm
They've just given one
sure
example of a pump.
because I know now we have fields in which we have big centrifugal pumps, and in where I'm like staying in Jammu, we don't have like water level too much and like close to the ground. It is very much down, so we use big pumps for irrigation.
Okay, so And reciprocating happening in cases of tall trees. Okay, so this like uh, water is moving in continuous.
What tall trees?
The similar thing is happening in tall trees.
No. It's, I think it's something else. You are. It's due to the capillary action. What is
No,
that?
capillary action पे वो limit है 1 atmosphere की.
So one thing, Gurvinder, the centrifugal pumps are like mounted on ground level or submerged?
Yes. Ground. And it's around too much feet. The height is very much down. Feet goes.
Definitely
The
Actually,
NPSH available is mentioned at the while buying the centrifugal pump, that इससे ज़्यादा हाइट करेंगे तो पानी नहीं खींचेगा.
so that's why we use big pumps, because big pumps have more positive suction height.
So then maybe we'll have to find out if this holds this 10.3. If not, why is it not why can we make an exception for centrifugal pumps is the most important question.
I have
in that
written
case.
this, na. Let's move
I
with
think it is mainly with the speed of the impeller, according to me. What do you say?
And my another thing I want to tell, in reciprocating pumps, no, there is a plunger is sucking the water, right? If the area of the plunger is more and the suction sucking, the means the stroke length of that plunger is high, then it can suck more deep water. Means it doesn't depend upon the like centrifugal pump. It is 10.3 meter, but if the in the reciprocating pump we can only apply the how much amount by calculating it. Right. And when the plunger compresses, more pressure can be developed, so it can send up to the more height. Because of that, a plunger is compressing, pressure will be induced, right?
I think plunger cannot like suck that much volume of water. That's can be the reason.
Uh, okay, tell me one thing. Negative pressure and vacuum same चीज होती है क्या?
हाँ.
So let's say I'm having 100% vacuum.
It means minus 1.0 bar.
Because what I was theorizing in my head is जो अपने positive displacement pump होते हैं, so they cannot drop the pressure. I mean, can you drop the pressure below vacuum? 100% vacuum के नीचे pressure का.
No.
नहीं
And
नहीं
Not practically.
okay, so just let it go. Let it. क्योंकि मैं ये
Because
सोच
it
रहा था
starts from minus 0.1, 0.2, minus
हाँ
0.2.
वैसा नहीं होता ना.
Not minus 1 से नीचे नहीं जाएगा minus 1 से. At least on Earth.
Yeah, it doesn't make sense anymore then. It has to do something with the like method pumps are developing that negative pressure.
Okay, just leave it.
I
Yeah.
have
Don't.
आई
written,
थिंक
guys.
आई थिंक
Uh,
इस पे ज्यादा टाइम मत दो.
हाँ
ये
यार.
पूछ लो कि
ये
जज
सब
साहब.
पूरा
क्वेश्चन
अलग
कुछ भी
अलग अलग
नहीं
अलग
है.
निकल रहा है.
इसके क्वेश्चन पूछेगा तुमसे सिर्फ वर्किंग ऑफ गियर
या
पंप एंड ड्राइंग ऑफ गियर पंप.
उस पे
बस खत्म.
रिसर्च करने चले तो भैया जज साहब लोग आप लोग जो है समय कम खाओ.
एक research
Okay. One question for the Gyan.
Contestant, yes.
Like, why we are using relief valve in gear pumps?
Because it can generate high pressure, and we don't use relief valve in a centrifugal pump because working pressure of centrifugal pump is not very much that the pressure that can be held, that can be resisted by the component of that centrifugal pump. But in this gear pump the working pressure is much more, that uh, that's why it's required relief valve.
No.
can I can I try
I'm not
Gurvinder?
satisfied. I'm not satisfied.
Can I try?
बराबर है. आई एम आल्सो नॉट
अरे
सेटिस्फाइड.
यार कब होगा सेटिस्फाई. आज मैंने एक इंजीनियर को अपना भेजा एक्सप्लेनेशन, वो कह रहा, वो भी कह रहा है नॉट सेटिस्फाइड.
Let Ashish speak.
आशीष.
Whenever when as you told that suddenly the at the discharge side of the this gear pump the suddenly the area will be decreases, so because of that pressure can go a maximum level. And in a positive displacement pump despite of the changes variation in the discharge pressure, the volume of the oil will be remain constant. So if there is anything the wrong happens in a discharge side, if it is get stuck or something, the pressure will suddenly can rise up to the means beyond the limit. So because of that the relief wall is set 7 bar or something. If it goes beyond that, suddenly the relief wall will release the pressure and it will maintain the pressure inside the pipe. Correct? Huh?
Yes, it's right to some extent.
What
I
he.
Just
guess
one more point.
simply you can also say that like in the gear pump or like in any positive displacement pump, if like the discharge side is choked due to any reason. So if it is choked now, so the pump will keep on developing pressure no matter what happens at the discharge side. So there's a chance of bursting the casing and even the pipeline. So that's why we give a relief valve, so which will just release the pressure. But in case of centrifugal pump, if for example if any blockage happens, so the pump will not develop higher pressure than its maximum capacity. The water will only keep on churning inside the casing, so there's no issue of bursting and like and this. That's why we don't use any reliever.
Bhaiya, what I had said also na, कि that on in case of centrifugal pump casing have that much उसमें ऐसा casing इतना
That
strong
much
होता
strength that it will never burst.
है. या और इसमें जो है भैया प्रेशर इतना ज्यादा डेवलप होता है कि.
तेरे पॉजिटिव डिस्प्लेसमेंट एक वर्ड को फोकस देके बोलो समझ जाएगा.
Okay.
इतना क्यों माथा पच्ची कर रहा है. सिंपल है ना.
But Gurvinder made a good point that I there is a chance of bursting, and the churn in a case of centrifugal pump, water will keep churning inside that. There will be
But
not a continuous develop of that
hmm,
much extent of pressure in a case
but
of.
they will also be one problem you can face in when the water will keep on churning. So can you tell me what was the problem?
Keep on churning, गर्म हो जाएगा.
हाँ, क्या
Cavitation,
गर्म हो जाएगा?
cavitation.
क्या गर्म हो जाएगा?
पानी भी गर्म हो जाएगा, कैविटेशन भी होने के चांसेस होते हैं if the flow
Water
is
will
becoming
boil.
in case steam start to form.
इतना नहीं नहीं इतनी भी हीट नहीं होगी, स्टीम बॉयल हो जाएगा। नहीं नहीं,
हाँ,
स्टीम
इतनी भी नहीं।
Pitting.
पानी गर्म होता है।
नहीं 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 नहीं।
Pitting,
you
हाँ।
can say the motor winding or they will get heat up and it can get
वाइंडिंग
damaged.
वाइंडिंग नहीं।
अरे भैया
तो
वाइंडिंग तो दूर रहेगा।
मैकेनिकल सील्स नहीं क्या?
हाँ, मैकेनिकल सील भी,
ओ
सॉरी
ओ
ग्लैंड पैकिंग भी हीट
ग्लैंड
होती है
पैकिंग
तो हाँ
डैमेज
हो
हो
सकती
जाएगी,
है।
हीट अप की वजह से, वेयर एंड टीयर ज्यादा होगा।
Wear and tear.
हम्म, or the gland packing can get burned.
Mainly, I've heard that
ए
if the
कैविटेशन नहीं होगा?
discharge valve is closed for too long, the gland packing might also leak by sustaining
It
that
can
high
get
pressure
burned.
for a long time.
अच्छा कैविटेशन नहीं होगा?
हाँ, मेरा भी वही सवाल है, कैविटेशन भी होना चाहिए ना?
If suppose there is proper net positive suction head, cavitation could be impossible.
No.
नहीं,
Cavitation also depends on temperature of that liquid in in
if the
casing.
water is living out, then there is nothing that is coming in.
Yeah, so whatever
The
water is
temperature
already there
increase
is
नहीं
is
होगा
going
तो
to be
फिर
rotating, but there's no air because I've already primed the pump before starting.
but if the what
Formation
if the
of bubble
temperature
can
is
be
not
possible ना,
increasing,
मिस्टर
ये
एविटो
टेम्परेचर अगर
लॉरेंसो।
पानी का इंक्रीज नहीं हो रहा फिर कैसे होगा?
अरे टेम्परेचर बढ़ रहा है तो पानी बॉयल तो हो सकता है भैया।
कैसे होगा टेम्परेचर इंक्रीज पानी का?
अरे वो गर्म हो रहा है, एकदम घूम रहा
Yeah,
है।
but suction water is coming in. No, infinite suction water is connected to the garam water.
No?
तब तक नहीं आएगा जब तक अगला बाहर नहीं जाएगा।
ज्ञान वेट अभी तो क्या होगा, सेंट्रीफ्यूगल पंप में नेगेटिव प्रेशर बिल्डअप इसलिए होता है बिकॉज वाटर इज लिविंग द केसिंग।
करेक्ट।
So if water isn't leaving the casing, there won't like development of negative pressure.
सक्शन
So
नहीं,
no
क्वेश्चन
water
सक्शन
is
नहीं
coming up.
होगा।
So the water which is present inside the casing will heat up. उससे अपना जो suction pressure जो होता है वो बहुत कम हो जाएगा। There won't be
जो
any being generated.
ये ज्ञान कह रहा है कि पानी बॉयल हो जाएगा, बॉयल होने से पहले तो उसकी बाइंडिंग सड़ जाएंगी, इतनी हीट हो अगर होगी तो।
नहीं थोड़ा बहुत तो
इसलिए
भैया
I think
दो
in
चार
this
पार्टिकल
case,
तो हो ही सकता है।
the best answer will be to talk a little bit about the curves of the pump, the pressure versus flow. If you have a look in the Dreamer, he has mentioned the curves. In centrifugal, what is efficiency versus flow? It's a straight line passing through origin, which means when flow is zero, efficiency zero. Efficiency zero means zero pressure is being developed. If the
efficiency remains constant throughout, I
no, in
guess.
centrifugal it cannot remain constant. It's based on flow. That is why when I close my discharge valve, the motor doesn't get additional load.
Efficiency is
But
not
coming to
constant.
positive displacement, what is efficiency? Efficiency does not care about flow. So if your flow is zero or it's 100%, efficiency is the same. Pump is working the exact same amount of power. So that is why what is going to happen is, what was the initial question again?
So, okay, the main question was what will happen if the water will keep on churning? You can simply say it will start producing heat and it can
Oh no
damage
no
the
no
gland
no no!
packing.
Now I remember. The initial question before churning was, why do we need relief valve in positive
Relief valve
displacement?
and positive displacement.
I agree with Kamlesh bro one point.
अरे भाई उसका आंसर हो गया पहले, रिलीफ वॉल का।
ठीक है।
No. So
क्वेश्चन है।
I'm connecting relief valve to the curves now. So in terms of the relief valve, what is happening in positive displacement? Positive displacement does not care if your discharge valve is open or closed. Efficiency is constant. It is independent of flow. If you have a look at just a straight vertical line.
Correct.
So what is going to happen is it is continuously pumping whether you keep your discharge open or closed. So pressure keeps on building because efficiency is 100% all the time. So that is why we need a relief valve in positive displacement. But what about centrifugal? It is a straight diagonal line passing through origin, which means flow zero, efficiency zero, zero pressure is additionally built. Whatever is there is just going to remain there churning around, but no additional pressure will be built, which is why relief valve is not needed. So this is one more analysis.
But okay, you Avito, you made all point agreeable, but the cavitation point you said na, I am more agree with Kamlesh brother that suction is only created when there will be discharge, when there will be water leaving the case, and the negative pressure, the suction if it is not happening, the suction pressure will get lowered, and then the water vapor pressure of water, and there is a chances of formation of water bubbles.
Can be. Maybe we can have Kamlesh just summarize the entire understanding of this question.
Actually, I'm confused with what I was saying, what you guys were saying.
No, no. See,
No doubt.
yeah, suction pressure means negative pressure, and and since water is not living and water is churning continuously.
You are right. You are right.
Yeah, thank you so much.
No suction will take place more.
And suction pressure will get lowered now, means negative pressure will get lowered, and negative pressure will get lowered to the extent that the water vapor pressure will overcome that
नहीं नहीं
vapor pressure of water, and there is a chance of formation of bubble. मैं इसको I will send the explanation of that how continuously churning of water can affect
okay okay
cavitation.
okay
Okay,
ठीक है
My
let
another one question is there. In priming, do you only remove the air or you will remove the air and put water inside?
both
And air can only be removed if the space of air is taken up by water. Otherwise, how will you remove air?
no we can use another pump which will remove the
that is
flow.
reciprocating
If you're
pump
using the
priming unit.
pump, then you are pumping out the air, and if you're doing manually, then you are filling up that pipe,
Hmm.
and the air will go out. Starting words as I didn't listen. Tell again, Kamlesh. Okay, so imagine you have to prime your pump at your well. Huh. So in that case, you won't use an external pump to pump out the air. What
Okay,
you'll
okay.
do, you'll fill up that suction pipe, and because of you are adding water, the air will go out. But if you are using a priming pump, then that pump out the air. Okay, okay. Huh.
Pumping out air basically means creating a suction, so it is pulling the water from down
Yeah.
to up.
Yeah. Okay. In which all case you will do manual priming, and which all case you will do means like you told the motor. In smaller pumps, we don't generally use like priming unit or like that.
Like if we are just sucking the water from the like very down below, na, we have to use a priming unit because there's a chance air
Or
can
let's
enter.
say
एक
your
क्वेश्चन
pump
है.
needs to be primed very often.
Okay, I have one question.
Then
We
normally we have NTR. That
okay.
sorry, what is that? Non-return valve.
Yeah.
Uh,
I have one question.
NRV.
Does we start? Does we start centrifugal pump? हिंदी में पूछ लेते हैं. ठीक है, हम ऐसे ही जो है सेंट्रीफ्यूगल पंप स्टार्ट करते हैं या सक्शन वाल पाइप में पानी भर लेते हैं फिर स्टार्ट करते हैं.
If you are non-return or like check wall जो foot wall जो बोलते हैं हम पंप में, अगर वो तेरा परफेक्ट है,
हाँ,
वो लीक नहीं कर रहा, तो तुझे प्राइमिंग एक ही बार करनी पड़ेगी.
क्योंकि हमेशा पानी रहेगा उसमें. देयर विल बी ऑलवेज वाटर.
जब foot wall डैमेज हो जाएगा या फिर उसमें कुछ फंस जाएगा, तो तेरा जो लाइक सक्शन पाइप है वो ड्रेन होता रहेगा और तुझे हर बार पंप चालू करेगा तो फिर से पानी भर.
ऐसा हमने देखा है जब हम पंप चालू भी करते हैं तो सक नहीं करता है, तो पहले खींच के हम ऐसा कंटिन्यू कराने के लिए थोड़ा खींचते हैं. ठीक है,
तो उस केस में तो क्या करना
पानी
है?
भी डालते हैं फिर वो खोल के वहां से नेट खोल
हाँ
के.
पानी भी डालते हैं. वो प्राइमिंग ही करते थे क्या हम.
हाँ वो प्राइमिंग
अब घर
एक
पे
टाइप की.
अब घर पे जाऊंगा तो कोई पूछेगा क्या कर रहे हो, तो मैं बोलूंगा आई एम डूइंग प्राइमिंग.
हैंड पंप को भी तो करते हैं, हैंड पंप को भी करते हैं.
हैंडपंप
देखा
If
होगा.
ये इंटरव्यू में अगर पूछेगा व्हाट इज फ्रेमिंग, देन वी कैन
गिव द
means
एग्जांपल.
like we have to say we can say that if your pump unit is fixed, then automatic priming only air will be sucked out, and if for manual priming he will suck out the air and put the water. Like that only we have to explain. If you are being asked what is priming, just simply mention that you are removing the air from the casing and suction pipe and replacing that air with water. And if he is asking what are the methods of priming, then mention manual priming and priming unit.
मेथड्स ऑफ प्राइमिंग
Okay.
में बता दूंगा सर, बचपन में
But
किया
like-
करते थे, पानी लेके डाला करते
और पता
थे.
है इससे पहले तो मैं ये चीज मेंशन करोगे ना अगर कि हमें क्यों कर रहे हैं प्राइमिंग तो वो बेटर होगा.
हाँ.
इसलिए
Then
that's
you can
this
even,
mention
if you want to make the
Mention
answer
why
even longer,
you
you can add density, all of that additional, space that answer over here.
in the
Of how
dreamer package
air is
also
less
sir
dense.
have explained before why we are doing then how we are doing. I think this is the better way to answer.
Okay.
One more possibility of where air will enter is, as I had mentioned, maintenance of the filter. So when you pull out the filter, you're opening it up to atmosphere, so some air will go in there. So after that, you can either purge the filter, which means before you put the filter back into use, you can completely fill it and overfill it basically with whatever water or oil. If not, you can just prime the pump.
Yeah. purging is removing of air and filling of water.
Yeah, so basically you just keep on overfilling the filter till it keeps on overflowing of just only water, which means if it is overflowing with water, there's no chance of air inside.
Does
Yeah, it's
priming
similar.
and purging is not similar?
It is similar thing, no?
Yeah, I just heard the nomenclature is called purging for filters, but maybe it can be used
नहीं,
interchangeably.
filter में like why filters are purged is that let's say you have a system
Why
which is
filters are
oil
purged?
like pneumatic hydraulic system you have, and in that you have your filter. Okay.
Yeah.
And if you're not purging that filter, then air will present in that filter. So
Exactly. When I open and close it, there'll be some air.
yeah, and which will affect your like performance of your like hydraulic system. That's why you
Yeah,
purge.
exactly. So exactly, I can either purge the filter, which is a small amount of
Yeah,
oil that I need to waste, or I can purge, not purge, but prime my entire piston or whatever, the entire machine again.
Okay, all right.
There also one favorite question of operator for the pumps.
What? Tell me now.
Why positive displacement pumps are called so?
yeah.
If
Positive displacement
That's
pump
our
are
answer,
called
brother.
reciprocating
if
pump.
if you can satisfy him, he will select you.
Yes.
Like
Yeah.
what
Which
is
is right?
So can you say one more time what are you saying?
Why
Positive
positive
displacement pump?
displacement pumps are called positive displacement pumps?
Yeah, yeah. Despite of the
Oh,
change in the discharge pressure, it is continuously pumping the fluid. Because of that,
Ye-
pressure will be increases. Means the flow will be constant. Despite of the variation in the discharge pressure, flow will be constant. So it is called as positive displacement pump. That much only. No? वो तो उसकी property.
Ashish, we actually don't know. I think no one knows the answer he needs.
What by that question he is trying to ask what exactly positive displacement this term is we are using, no? What does
No,
exactly
if I
mean?
will
No, he
I
is
have to
asking
answer na.
why positive displacement
Okay,
pump is
yeah,
called so.
let
He is
Gyan
asking
answer.
that.
Okay, okay. Sir, suppose a example of that Pichkari. Okay, it's an also a positive displacement pump. Here, when we Pichkari pitch, there is displacement. There is displacement, and we apply force and displacement in the same direction. That's why it's called positive displacement. And what we are doing on that is called pump. Thank you, sir, for selecting
जब
me.
मेरा इंटर जब मेरा इंटरव्यू है तब तो मैंने ऐसा किया था रेडी कि the positive displacement pump always displaces pump because in these pumps no water ever comes to its back to its casing. Whatever pump it is pumping, it will go out no matter what happens, and it is displacing it positively.
Can we say like this in like let's say you are having a positive displacement pump, you are applying the force directly on the fluid.
Huh.
Let's say if you are having the centrifugal force and centrifugal pump, then in that case the negative pressure which is being created is because of the displacement of fluid, which is happening because of pseudo force, like that is the centrifugal force, and not because we are
I
applying.
think the best answer will be that in centrifugal pump you can have churning, which means water that has been compressed can be compressed again and again and again because there's no way for it to go. But the same thing in a positive displacement pump, if you see, like in the diagrams that I've drawn, you will always have a non-return, like the gears meshing or the lobes interlocking. So there's no chance for water that has been compressed one time to ever come back to your suction side.
Because it creates a locking. You can see like
So you can
in
maybe mention this kind of an
any
example
type
of
of
taking
pump.
any gear pump, and that might satisfy him better.
The rest it depends on him what he wants. You can
I
try your
hope
best.
that he doesn't ask this question because no matter how hard he try to prepare, he's not gonna get satisfied. I know that.
When I had him for my interview, he was kind of a very chill guy though.
Who was that?
मुझे लगता है हमारे बारे में
Vaporizer.
भाई वो कैंपस में थोड़ा सा था चिल कैंपस प्लेसमेंट में.
Any Gurvinder, if you see him, no, he's very chilled. I mean, like when you're talking, you won't feel any aggression or like.
Yeah, so he'd be like, so tell
Right?
me, what
He's,
about this? What about this?
he's very chill and supportive guy. Like तू scared feel नहीं करेगा उनके सामने. ये बात
हाँ दिया मैंने उससे इंटरव्यू. आई थिंक मुझे ऐसा फील हुआ है जो मैंने सारे लोगों के देखे ना
Mhm.
क्वेश्चंस, मुझे फील हुआ कैंपस में था थोड़ा लीनियंट, मतलब मिसलीनियस तो एक भी नहीं पूछा, जो उसके मिसलीनियस है दो चार
कौन कौन से हैं वो?
है, नहीं है उसके एक दो और की, वो था एसी इज इन टीआर एंड फ्रिज इज इन
ओके।
लीटर्स,
हाँ, हाँ,
वो भी नहीं पूछा।
He
एंड
believes
दिस
in
वन,
of NIT.
हाँ
वो NIT के सिलेक्शन प्रोसीजर पे बिलीव करते हैं, so that's why they like
I
इनको ज्यादा
guessed.
पूछ,
Uh,
already they have one milestone.
you
ये
already
एक
got an
आंसर,
IT credit, यार. यार, let's
what
move
is
with the
this
next
answer for
question.
why refrigerant is in a TR
Yeah,
and
there we have
this one?
already discussed, bro. I have
हाँ.
uploaded all the
चलो
videos with the proper
लेट ज्ञान
description.
एक्सप्लेन दिस, लेट ज्ञान एक्सप्लेन दिस
Okay.
ज्ञान एक्सप्लेन।
Actually, freeze can also be measured in turn refrigeration, but the proper question is why we buy a freeze in with a cap with after seeing the TR and freeze in liter, because we in freeze we are concerned about the capacity, okay, the capacity of cooling, and in case of freeze we are concerned about the storage, okay. And the proper reason is like in a case of AC, there is a there is a continuous heat source like for which has to cool, that is not a constant, like it is a continuous body. If we take an example of AC and there is a some source that is like a man, we don't have a perfect thing. If we consider freeze, in freeze there are vegetables that are at constant temperature, that is not continuous. So in freeze we are only consider about that स्टोरेज थिंग। यार यार मैं भूल जाता हूँ, ऐसा ही कुछ है ना?
Basically, very simple.
अराउंड
In
अराउंड
fridge, we are considering regarding the storage capacity in liters. Water is stored in the bottle in liters. So same thing, we're just taking a bigger version of that. Imagine your fridge, how much storage, how many like days of people's worth of food you want to store. That is what we are measuring over there. But in the case of the AC, we are measuring the cooling performance. So even in terms of the fridge, we can measure how good is the compressor, what is the size of the compressor in terms of cooling performance. But when I'm buying the fridge, I'm more interested how much can I store in that fridge? Can it take my large utensils or not?
Correct, yeah. Yeah, that's why I'm so upset with
Got it, bro.
myself.
Can I try to answer this question?
uh,
I have slightly different.
okay, okay.
So, what's happening in this case is, in case of refrigeration, you know the exact volume of your like refrigerating, like the unit which you are trying to refrigerate. Okay, there aren't anything which will be like producing it, so you won't need to. You know how much heat should be extracted. So you can specify this unit will cool this much amount of volume, which is relevant to the buyer as well. But in case of air conditioning units, you don't know the exact, like, let's say I'm a manufacturer. I'm not manufacturing a unit for specific dimensions. I'm like manufacturing one unit which can perform in a range of dimensions of room and range of people operating in that room or like appliances. So that's why it makes more sense to like mention the cooling capacity of the sorry, air conditioning unit. And in case of refrigerator, we are more like it's more relevant and convenient to like mention the volume of that cooling chamber. Got it, bro.
Correct, yeah.
It's
Yeah,
messed up the question.
see, by the end of the end, by like when I will be having my interview, till then I need to organize my answer. Yeah, I'm so upset while delivering the things. I am not that. We to delivered, the delivery is quite good, was quite good, and I am not satisfied with my delivery thing. Like I also had the idea of what is really concept behind, what is the real concept behind AC is in TR and freeze in liter. Guys, one day when I will be able to that reach that point, please let me know. Okay.
Yeah,
Yeah.
yeah. No, what I was asking, whatever I said, is that making sense to anyone of you guys, or I just. Yeah, I got it. this what you said.
मैं पता है कैसे करता था ज्ञान। मैं क्वेश्चन लिख लिया, उसका आंसर लिखता था पहले पूरा, फिर उसको रिवाइज करेगा तो तभी होगा, नहीं तो नहीं हो पाएगा।
Yeah, I also do the same stuff, but instead of writing the entire answer, what I do is I make the key points or keywords.
मैं तो पूरा वर्ड टू वर्ड जो मतलब प्रॉपर जो इंटरव्यू में
Kiran
देना
also did
है।
same. Yeah.
Ratamar.
क्या? No, see, actually, what is
ये
the
कॉन्सेप्ट तो हम सबको है कि क्या
कॉन्सेप्ट तो
क्या
हमें पता ही है।
कॉन्सेप्ट है।
हमें हम इससे क्या करेंगे कि हमें स्टेप बाय स्टेप कहाँ से क्या बोलना है।
हम्म,
अब while explaining this centrifugal pump, मैं बर्नौली कब बोलना है, डेंसिटी कब बोलना है, ये सब नहीं पता। जब जो समझ में आ रहा है वही बोल दे रहा हूँ, ठीक है। दैट इज द ओनली डिफरेंस।
वो जो सीक्वेंस रहता है ना,
हाँ।
लाइक ऑर्डर, वो
वही मैटर
वो
करता
बना ले।
है।
अगर पूरा आंसर नहीं बनाना तुझे तो एटलीस्ट वो बना ले कि लाइक ओके, इस पॉइंट के बाद ये पॉइंट आएगा, इस पॉइंट के बाद ये पॉइंट आएगा।
मैंने इसको मिसलिनियस को तो लिखा था अच्छे से, पर पूछा ही नहीं किसी ने। चलो सही है।
So guys,
And
can
purpose of seawater in engine, what it is? Means like purpose of seawater in
Ashish
engine.
bro will discuss this in next
Purpose of
meeting.
seawater in engine basically,
Uh,
in like basic concept, you can say it for used for the cooling purposes.
yeah, in condenser only, for that only, no?
In the engines, now you are asking the main engine.
What the
In
watched the
engine करके
video
they
by
have
Pradeep
asked,
sir on
yeah.
What?
tracing the paths. It showed it goes to LT cooler.
What?
I'm not